Hello everyone and welcome to another episode of the We Are Developers Live Days. My name is Bene and I'm happy that you all joined us today. So today is all about security, but before we start with this very important topic, quick reminder for our regular viewers and as an information for our newcomers, the WeAreDevelopers World Congress is back as an in-person event. This year it's from July 17th to 19th in Berlin. Check out worldcongress.dev. They will get further information and you can also claim your tickets. And now, before we start with the first speaker of the day, keep in mind, you can interact via the chat to your right. Submit some questions if you got any. The speakers will gladly answer them after their talk. But as usual, please keep in mind to respect each other and to be nice to each other as we have a code of conduct. Here's a short video about it. And let's kick off the security day with our first guest. He is co-founder and CPO at Cerbos. He already worked as an engineer, consultant, tech lead, and even product manager. But one thing he kept throughout all his professions, he always had an eye on the developer experience. Very welcome, Alex.
Hi, how you doing?
Hi, Alex. I'm doing awesome. Hope you're too.
Yeah, I'm doing great, thank you. And thanks for having me as well. Looking forward to chatting.
Yeah, thanks for joining. So, Alex, before we jump into your talk, would you mind sharing a bit with the audience and me what your talk is all about?
Yeah, absolutely. So today we're going to be talking about authorization, which is kind of the brother or the sister of authentication, that bit that happens in every application code where you need to work out whether a particular user can do a particular action or not inside of your system.
Awesome. So all about the very fundamental concept. Looking very much forward, Alex. What a topic to kick off today. And I would say, before I steal any more of your talking time, the stage is all yours.
Excellent. Thank you very much. And hello, everyone. Hope you're all doing well. Good morning, good afternoon, good evening, depending where in the world you are. Very happy to be here today and thankful to be asked to open up the talks today. So as I mentioned, I'm going to talk about uncomplicating authorization maintenance and really kind of digging down into what this whole problem space is. You may be doing this today without realizing it. This is maybe something you're tackling. This may be something that you know is this big task in the future, which you don't necessarily want to go and build yourself. So we're going to kind of go through the journey and then the life cycle of a product or a business and sort of see where this kind of maintenance or where this kind of effort comes in when it comes to authorization and a different approach, a new approach to solve it with the open source project Cerbos. So quickly about me, you had a bit before, but I am an engineer at heart, but unfortunately I maybe lost track, got a bit lost on the path in a previous life and ended up into the world of product management. But I really do still write code day in, day out, which I probably shouldn't, but there we go, I do. But I started my career at Microsoft doing kind of technical consulting type things, and then very quickly moved into the world of SaaS startups, which are way more fun in my personal opinion, and worked in different industries. So marketing technology was a big one. I was kind of building running systems that were processing 20 billion requests a day through them. So kind of large scale distributed compute data processing type problems. Same with like e-com, worked in supply chain business for a bit. So, shipping containers from the Far East to Europe or the US and kind of the logistics and the data flows involved with that, not just physically moving the containers, and these are physical containers, not Docker containers, from one part of the world to the other. There's all sorts of data and access control challenges around that. So who's allowed to view the shipment? Can the customs broker access this particular container? Can this particular business view the purchase order and everything? There's a very kind of complex web of problems around that. And then connected fitness I worked in as well for a bit. So think of your like Peloton type systems. Here you're having your users, your customers, your consumers. It's their fitness data, it's their heart rate data, and you have to be very strict around that kind of how you control and how you model access to that. So there was a common theme across all these kind of businesses I worked on, which is around this sort of data DevOps infrastructure kind of focus. So making sure that not only we had a solid data platform, but also access controls and permissions and the security around it was sort of solid and was a solid foundation for the other product teams and the other engineering teams inside of those businesses to go and build on top of. And one of the things I kept having to rebuild, both as the guy that coded it, but also as later the product guy that sort of spec'd out and defined the requirements for it, was this authorization piece. And where this really comes down to what it looks like inside our business is you end up having to dedicate around 3 months of engineering time to go and build this layer that can really work out, can this user do this particular action on this particular resource? And I was always kind of annoyed there wasn't an off-the-shelf solution to it. So about 3 years ago, we created an open source project for this called Cerbos. We have a business built around it as well. So we have the core maintainers, but then we have a commercial product that sits on top. But the core engine of Cerbos is completely open source. I'm not going to dwell on that. I'll touch on it at the end as a reference example. But that's kind of my background. So just to be sure we're all on the same page, I've said authorization a couple of times now. Just be very explicit that authorization and authentication are 2 different processes, or 2 different steps. So authentication, which unhelpfully seems to get reduced to auth-n quite often, is about a understanding or knowing or verifying who a particular user or a particular service account is. So this is typically the flow where you present a credential, some system verifies that credential and gives you back an identity. So you're probably all familiar with your login to your Google account, login with GitHub, things like OAuth 2 might ring a bell, using things like JSON Web Tokens to pass around credentials, those kind of things. That's all the scope of authentication. So establishing a verifiable identity from some issuer and those kind of things. And I would say this is very much sort of a solved problem these days. If you go back 10 years ago, you might have to go worry about creating a database, having inside that database a users or a credentials table. You need to worry about passwords and then hashing those passwords, hash and salts, if you remember all those kind of things. These aren't really things you have to worry about anymore these days. There are some great off-the-shelf solutions that do this, both free and commercial. So you can go and look at like Keycloak. If you look in the Cloud Native Computing Foundation kind of ecosystem, in the commercial side of things, you've got things like Clark, Super Tokens. Those have kind of open source components as well. And then you've got things like Okta, Auth0, Active Directory, if you're in kind of the Microsoft world, or Entra ID as it's now called. These are all kind of authentication solutions. What we're going to talk about today is the next step, which is the authorization. Again, unhelpfully reduced down to Auth-Z quite a lot of the time, or Auth-Z, depends what part of the world you're in. So authorization is the step after someone's authenticated and they're trying to interact with your system. Are they actually allowed to do that particular action inside of your system? And this really is the flow where request comes in. You have that authenticated request. You've got some sort of identity. You might have a token. You might be able to look up against an IDP provider, but you now know who the user is, and you also know what they're trying to access inside your system. So they're trying to view a report, edit an expense, download a document, the actual kind of action side of your system, and you need to authorize, basically check whether a particular user can do a particular action or a particular resource inside of your system. And this is the area we're going to be talking about for the next 30 minutes or so. And that's authorization, or Auth-Z, separately in a different step to authentication. So I think everyone probably is aware of this quote from Benjamin Franklin. In this world, nothing is certain but death and taxes. Having worked in this space for about 10 years now, or adjacent to the space for about 10 years now, I would love to extend this to and the ever-changing authorization requirements from every product manager or engineer or security team in a business out there, or even building your own applications. Without fail, you will build and design your authorization matrix or your access controls or your roles and permissions matrix inside of your system. And then might be a week, might be a month, might be 3 months, might be 6 months, might be a year. But at some point, those requirements are going to change. And there's numerous reasons why those requirements might change. And then you have to go back and touch all this application code, which is currently enforcing or checking sort of these permissions. And this is only kind of exacerbated as you start supporting different authentication providers, or you want to start locking down access to different feature sets, or you want to go and start supporting different access control models. So what does that look like, and kind of when would you need to worry about it and when you would think about it? And hopefully some of this will ring true to you now. Some of these may be things that are potentially 6 months ahead of you, might be next year from now. So it might be a bit of a therapy, a bit of a catharsis to kind of hear the story grow, or it might be a bit of a heads up, or maybe something you might need to think about as you're building and growing your product, and that could be you're an indie hacker building some amazing SaaS yourself. You might be inside of the company, but these lessons kind of ring true across all those kind of environments. So for this talk, we're going to pretend let's go and scale a company. So you are just starting out. You've got your application kind of stood up. Maybe it's a very basic MVP, or maybe just a POC, and you want to kind of get going fast. So I'm going to call this the blissful days of roles. And this is where you have a very simple check inside of your system that figures out, okay, if this person is an employee or this person is like the admin of the system, they should be able to do everything, or they are not an employee or an admin, thus they shouldn't be able to do things. So if you were to get implements in your code base today, somewhere in your application code, you would probably go and hard code this sort of logic. Imagine it's in like your request handler or maybe some middleware inside of your, say, Express server for a particular path or particular requests. You would go and put in some logic that says, okay, if the user email includes the company domain or the domain name you're using for your admin users, then the action should be allowed. If they haven't got that in their email address, then the access should be denied. And this is kind of the most crude, quick and dirty, get up and running quickly type setup that I've done in the past, and certainly will probably do in future as well, just to get things moving, get things going, and be able to lock down access to certain parts of the system. And yeah, you could potentially go and use like OAuth scopes. So if you are plugging into an external authentication provider, the token it might give you back might have scopes attached to it, or you're able to add scopes to it. And this is potentially one way of doing it. You could have a scope called like admin, and then you just have a check in your code base that says if user scopes includes admin, then allow the request. But this is kind of the most sort of naive access controls that you are likely to go and implement, or may have implemented already inside of your system. So let's go to stage 2. So you've got your basic version out. You maybe have a few different feature sets, a few different capabilities, and maybe at the point where you're at kind of revenue. So you have a sales team, or you have product-led growth type tactics on your site where people can sign up and get access to different systems. Or you might have an outbound sales team now that is trying to position and sell the product into the market. And one of the things that will, I guarantee, happen is changing how you package your product, or basically how you combine different features into different offerings that ultimately you're going to sell via that outbound motion, or by someone upgrading to, say, the pro tier or the enterprise tier, etc. So now you need to have this concept of like package sort of inside of your authorization logic. So if we go back to the application code that we hard coded earlier, so now we want to do this check where access to a particular route, a particular path should only be allowed if you're an admin. So again, we still have this check in here that looks at, say, the company email address. But we also want to check if this particular function should be allowed if someone has the premium package. So now we have this like company object, let's say, that's sort of their subscription. There's an attribute that says what package they have that's available to your application code. And you just have a simple check that says, okay, this person's on a premium package, it should be allowed. So, okay, you've now gone and touched and have to update your code base. If that package name changes, you might have to change that string. Or if you change the structure of your object, you might have to do it. And your application now might have a bit more complicated. You might have a dozen different API routes, or multiple dozen API routes, and this code essentially is going to have to be as part of all of those. And you can kind of extract this out into maybe a middleware and keep it quite simple. But ultimately, this logic is replicated across different parts of your code base. Another way you could do this, maybe look at like feature flags. So the open feature project, maybe one way you could do it. You've probably all heard of things like launch darkly. That's another way of looking at it. But basically, there's some sort of identifier, some sort of attribute about either the user or maybe their subscription or the company they're attached to that defines what their access should be. Cool. So let's go to stage 3. This is one that's kind of most painful to me. This is one that's caused me the most sleepless nights in previous businesses, which is selling to other regions. So to tell you a bit of a story, I mentioned I kind of worked on an e-commerce MarTech platform in previous role. And I was the product guy responsible for basically the data platform that our entire system ran off. So we were streaming in real-time clickstream behavior, sort of like Google Analytics style data, and then building recommendations and personalization models on top. And one of the challenges that I had to face, let's say, or one of the dynamic environmental factors, let's say, that I had to face during that time, and this was back about 10 years ago now, was when the safe harbor agreement between the Europe and the US fell through. And for those who don't know, Safe Harbor Agreement was basically a data sharing, data access sort of security legal agreement between the EU and the US to allow EU and US companies to basically interact with their user data. So data from European citizens can be accessed by US tech companies and sort of vice versa. And that agreement fell through. And it was basically what led to GDPR becoming a thing. So what we basically had to go through is bifurcate our data. So we had to look at, okay, who's this data? Is it for an EU client? Is it for a US client? We had to split our systems, split our data pipelines. And that was more of like the fundamental architecture type question. We had like 2 databases and 2 different AWS regions, for example. But then we also had to implement the authorization layer as well. So now we need to do a check, okay, for the person making requests to our system, are they in Europe or are they in the US? And then dictate access based upon that. So now, in the most sort of basic form, that if statement we had before, so check if someone's an admin based on the email address, or see if the person has the premium package. Now we have to do an additional check to see what region the user was making a request from. And then that would decide whether they should be able to access a particular data or report or a particular database, let's say. So this logic now had to go need to be updated. That was kind of sprinkled across all our code base to make sure we were enforcing this kind of data locality check. And when you want to scale out your business, maybe you start selling primarily in Europe, you want to start selling in the US, these are the kind of things you need to start thinking about around what your access control model needs to be. And this is, there's other ways to do this. You could potentially now also have an additional scope in your token that says what region this data belongs to and who the user belongs to, sorry, and then have checks hard-coded like that. And there's kind of language-specific libraries that can help you with this. So can in the Ruby ecosystem, Castle in the Node world. There's very kind of language-specific or implementation-specific libraries that you can use for this that can kind of maybe extract or abstract some of this away from the application code. But ultimately, every path in your application now needs to actually have this additional check, and you're going to have to do this kind of maintenance work to kind of keep things up to date and make sure that your application is enforcing your permissions properly. Cool. So you got through that. You now know your access model's in place. You're checking roles. You're checking who's admin. You're checking who is getting access based on their region, etc. And let's say your business is kind of doing well. Your little indie hacker SaaS is now growing up. You graduated. You've got those initial first sales coming through the door. And now, inevitably, at some point, the question about like, okay, what's our enterprise offering going to be? And again, this is one that's very close to my heart. I, again, was working on a different platform previously, and we were selling majority to the kind of smaller teams and smaller businesses. And then we started having serious sort of sales discussions with larger enterprises. So 2 instances come to mind. Worked with kind of one of the biggest office supplies retailers in the US, and also one of the big airlines in the United Arab Emirates in the UAE. And they wanted to buy our system. It was like, great, it's amazing. Just, lay out the red carpet, make sure they're happy, make sure we do everything they want, and ultimately, how do we position our product to kind of these 2 enterprise organizations? And one of the stumbling blocks, or one of the friction points you could say during kind of the sales process, is around how you onboard their users to our system. And our system at the time had kind of a very basic set of roles, kind of like we saw here. We had whether an admin or not, or what package they had, and that defined access to our environment. But the issue you kind of run into, or the challenge you run into once you start bringing on these larger businesses or one of these larger enterprise companies, is they're going to be onboarding hundreds, thousands, tens of thousands in this case of the users to your application. And these businesses internally have these very strict access controls and models in place, and members are users or employees ultimately are divided up into their different groups by region of the world, by department, by seniority, let's say. There's a lot of work that goes inside of big enterprise businesses to set up their directory ultimately of how their employees and how their users are defined and they're modeled. And they'll be using Active Directory being the most common one, maybe LDAP, technology you might have heard of. And so suddenly we want to onboard these 10,000 users or 20,000 users as we had to. They turn around saying, well, you only have 3 roles. We can't onboard 20,000 people into those 3 roles. You need way more fine-grained permissions than this. And so we had to go back to the drawing board a bit. And it's like, okay, well, now we need to support this kind of new access sort of definition based on some external data we're getting, which was from like a directory system. of our customers, or how do we give them more fine-grained permissions, or how do we give them more fine-grained roles and groups to access? And so you might end up going down the route of, okay, well, let's go and create the concept like user groups. And so you might have a European marketing team user group. You might have a West Coast US accounting group. You might have a East Coast, Southeast Asia finance group, let's say. And so you now have these kind of group definitions, and you sort of put users into these individual groups. And that's now an attribute about that particular user that's associated with them. And then in your application code, you now need to go and figure out, okay, which paths or which methods can these particular groups call, and you end up having to extend that authorization logic that you hard-coded into your request handler. Okay, first check if they're an admin or not, then check their package, and then see if they got a particular group membership, and then check what region they're in, and then that basically comes down and boils down to what the permission should be. And maybe you can use like custom directory attributes for this. You end up like having to query out a directory, let's say, or pulling in those attributes and stuff them into a token. You're now worried that your web token, for example, might be getting too bloated. These things do have a size, and they do have to be passed around through your request chain. That does have an impact at larger scales, and things start to kind of break down a bit. You might muddle through. You might get a solution for that. The next fun one is, okay, you now reach a scale where you want to go out and get your regulatory certs. So SOC 2, ISO 27001, PCI compliance, these kind of things. Depending what kind of business you're in or what stage you are, these things you might need much earlier. So for example, if you're doing anything with payments, you're going to have to be PCI compliant much earlier. If you do anything with like data, you're looking at things like, medical data, you might look at like HIPAA compliance. And all these come with requirements around access controls and permissions. And I was the one in another company where every year an auditor would come around for ISO compliance. I would get dragged down to the dark, dingy basement by this auditor, and I had to go through a load of security stuff with them and not only explain, but also demonstrate how we did things like access controls. And one of the key things with that is having a good audit trail. So for every decision your application is going, how do you demonstrate to your auditor for your compliance certs that you have these controls in place? I will happily admit I would have to sit there and like try and grep through S3 logs or CloudWatch traces or dig through Datadog and try and like show, look, we did deny requests, honest. But it was a mess. We were looking for like HTTP requests that returned a 402 and sort of hope for the best. There are much better ways to do it. So you then have to go through this route. Okay, well, how can we implement audit logs into our system? So not only are we checking permissions, but capturing that a decision that was made around access controls. So you might go and find some like logging library that will do this for you. And then inside your application code, at the point where you've made a decision, either an allow or deny, you then have to like implement these audit log calls inside the right place in your application code. So here we've added like check, we're logging out via our audit log that a fetch was done from EU or US, or a fetch was denied based on the kind of permissions that we set up. And this will give you kind of that nice, clean, structured audit logging of exactly what's going on. But it's effort. Our application code base now, we're a bigger business. We've got customers, paying customers, enterprise customers. Our application code isn't going to be this very simple. We're going to have this logic kind of replicated in different routes and handlers and different parts of our application. And this problem only gets exacerbated when you go to the world of microservices, which that discussion will inevitably happen at some point inside of your system, inside of your kind of maturity curve. And this can happen much earlier or much later, depending kind of how you design and build your system from day one. But this also has an impact in terms of the maintenance involved with authorization as well. Because now ultimately what that means is all this logic that you've hard-coded and maybe you've packaged up into a nice library that you're importing inside of your Node application or inside of your Python app or Go, etc. This is ultimately the hard coding as application code or as source code, your business logic. And what that now means is when that business logic changes, you're going to have to go to every single one of your microservices, which might be in all sorts of different languages, because a heterogeneous architecture, you might be doing your front end in React, your back end for your front end is in Node. You might have some data science ML thing going on in Python. You might have your authentication layer happening in Go. You might have some legacy component in .NET, let's say. And what that now means is each of these services is going to have to some degree, re-implement this authorization logic. So when those requirements change, so you want to add a new role, you want to add a new product packaging, you want to go and update your audit logs, let's say. that is ultimately like a change request from more the business side of things, let's say. And then you're going to have to go and find the resources who can write and understand the different services in each of their different languages. So you're now probably going to be touching multiple teams inside of your business. This team, which may not have the historical knowledge of how authorization was implemented, they're going to have to go into their application code, and they're going to have to then go and take that business requirement and write it as code in that particular language. And now this is just opening up the door for kind of errors or potential conflicts or misinterpretation of the business requirements. But because it's going to be in different languages spread across your code base, it's going to be a bit harder to catch. Testing now becomes very, very tricky because you now have to test things in different languages and different services. And then each of your services is going to be updated and then tested and then rolled out. And you have to make sure all your services that do authorization are updated and rolled out consistently. So your production environment now has all the logic in. And there really wasn't a solution for this when I went kind of through this journey. So what would a new approach be? So I mentioned this kind of a few times now. We're in the world of kind of build versus buy in question in sort of quotes versus some sort of as a service type solution. Everything we've sort of looked at up to now is we're like hard coding this logic. We're building it. We made a decision to build it into our application code, hard code that logic inside of our system. But we're in the world now where there are so many off-the-shelf solutions for things. So authentication, for example, I mentioned Auth0 is kind of the one that everyone knows, but there's other solutions out there, Super Tokens, Citadel, Clerk, just to name a few that are sort of front of mind at the moment. But the benefit is actually a lot of these solutions for doing things you need are actually open source as well. So your buy, in quotes here, isn't actually a financial buy, but you're picking a solution off the shelf, which you can then plug in, and that solves that particular problem inside of your architecture for you. Or you can go, there's inevitably going to be a SaaS solution for the thing you're trying to solve as well. So when you're going through, if we kind of go through this journey where we're updating and changing our authorization logic, if we were to kind of imagine at the time sort of what would authorization as a service sort of looks like. So at a high level, you have a request coming in. You know who that user is or that authenticator session is. Based on the request, what resource they're trying to access inside of your system. And also based on the request, what action they're trying to do. So you could look just purely at the HTTP verbs. Are they trying to get, up, patch, delete, post, etc. A particular resource they're accessing, or you could be a bit more sort of fine-grained than that. You might have an endpoint called approve for a user trying to approve some action, do the approve action on some particular resource. So that comes in. You want to basically pass that to some sort of authorizing service. So that authorization service in it has basically that logic or that policy loaded into it, which defines what those business requirements are. So the authorization service takes a request in of user resource action. It evaluates the policies that basically define what the access control should be, and then it spits out an output, and the output, and the most basic, is going to be either an allow or deny decision. So yes, go on, allow the request go through, or no, return back the application and say, this shouldn't happen, give them an error, return a 402, those kind of things. So if we go into the policy particularly, so the advantage of moving to more like a policy-based approach is no longer application code. So your complex authorization logic can now be defined as something that's firstly is agnostic to any particular language or framework or architecture decisions you made. It's a static asset which defines your authorization logic. What you see on the screen here is an example of a Cerbos authorization policy. And this is defining the permissioning or the access control model for your application. And here we're looking at a resource inside of a contact resource, imagine like a CRM system. And we're here we're defining all the different actions and under which scenario those actions should be allowed. And so this is where you can do basic things like a term you may have heard is RBAC, or role-based access control. So we can check whether, for example, whether someone has the admin role and then allow the action, going back to that very first example. But then you want to get into the more fine-grained pieces where you want to check whether someone's in a particular department, whether they own the particular resource, whether the particular attribute they're accessing is, the particular resource they're accessing is published or active or not, and making decisions based upon that. And this is where you get into ABAC, or attribute-based access control. So here we're actually looking at individual attributes about either the user or the particular resource they're accessing. And the best example of this is you could never define a role of owner in a role-based access control system, because for an action to be allowed by owner is contextual based on who's making the request and the owner of the particular resource the request is being made against. So in kind of like database data model terms, your request comes in, you have a token that identifies the user. That user has an ID in it. And in your resource or in your database, you'd have a column on that resource called like owner ID, which we populated with that ID of the user that kind of made that particular resource instance. And so to enforce this owner permission, you would have a check that says, okay, is the ID of the person making the request equal to the owner ID field or attribute of the resource they're accessing? And this is all stuff that's very easy to kind of hard code into your application, but then you're going to have to hard code it in every language, as we saw in kind of the pains as things grow and scale that we kind of ran through. By pulling out into policy and something that's kind of agnostic and statically defined, you are decoupling it from the code and defining it in a way that's agnostic to the underlying system and the underlying languages, and actually something that's a bit more human readable to maybe people that aren't developers inside of your organization. So that's kind of puzzle piece number one, which is like, okay, extracting out into this policy file. So the next thing is like, how do I actually then go and enforce and check permissions at kind of request time in a way that is scalable and sensible and clear to what's going on? And thankfully, we're now in the world of kind of Kubernetes. Sidecar pattern is something that some of you may be familiar with. But ultimately, you would have your application running or your service running inside of your cluster. And inside of that pod, inside of that group or inside of that resource inside of your cluster, you can also run sidecars. And sidecars are just another container that runs right alongside your sort of main application container. And this is a pattern that's used for things like authentication, logging metrics. If you're familiar with things like Istio, servers meshes, those kind of things. And this is useful because it co-locates a service alongside your application, which means any calls to that service are essentially local host. You're not going off the actual node. You're not going over the internet. You're making a call that's literally like calling another service running on the exact same machine inside of that pod. And this is actually a really useful pattern when it comes to authorization as well. Because what it now means is each of your microservices that may be in different languages can have running alongside of it this authorization source service as well. So when they need to check permissions, it's not having to go and query a database. It's not having to go and query something over the internet, which is going to be slow. Doing authorization via a web API is architecturally and performance-wise a terrible idea. You always want to make your authorizations happening locally as close to your application as possible. So this sidecar pattern really lends itself to things like authorization as well. So if we kind of zoom out a bit and look in practice what this would mean from your kind of architecture, this is a sort of a diagram. We're looking at a single sort of request into your system all the way through its life cycle, and then coming back out and making that decision. So on the left, we have our end user. They're going to be interacting with your system. It could be a web app, it could be a mobile app, they could be hitting an API, but ultimately there's some end identity. Could be a user. Equally, it could be like a service account or an API key, etc., making requests into your application. So that request would come in. It would come into your infrastructure. If you're running, say, Kubernetes, it will land in your cluster, might go through an API gateway, etc. But at some point, there's going to be a container or service or a handler that's going to do something with that request. And when that request comes in, you kind of know two main things. So we're assuming here that an identity provider or an authentication layer has already happened. So when a request hits your application in the session or the header, you might have a token or a way of ultimately looking up and verifying who's making that request. And you can go out to maybe a directory system, go and look up further attributes about that particular identity. What team they're in, what groups they belong to, what office they're in, what part of the world they're in, whether they're on the VPN, these kind of types of information. The second thing based on that request is what resource they're trying to access. So they're making a GET request to the expenses endpoint for expense ID 123. So you can go out to your application database or some external service and go and fetch that particular resource back. And now in your application code, you now have, okay, here's this user, all their attributes. Here's the resource and all the attributes. And what we're not going to do is fall into the trap of then hard coding that if-else statement that we ran through to work out whether this particular request should be allowed or not. We want to utilize this sort of external decoupled authorization service that we deployed. So in our architecture, we've run and deployed an instance of an authorization service. Could be Cerbos, or it could be one of the many other solutions out there for this. And that's running right alongside our application. And now in our code, using that authorization services API or SDK, we're going to make a call out to that authorization service. And there's 3 bits of information we're going to send in that request. We're going to send the principal, so the user or the identity that's making the request, its ID, its attributes. we're going to send the resource. So this is the contact resource. It has ID 123. It's part of this region in this office. Here's the owner, etc. And we're going to pass through what action is going to be done. So they're trying to read, create, update, delete, approve, deny, comment, flag, whatever the sort of actions that the end user is trying to do on that resource. So that request goes over to that authorization service. So that authorization service has loaded into it policies. So in the case of Cerbos, we support the concept of policy repositories. But ultimately, there's a mechanism here where the business logic, those sort of statically defined policies, are loaded in. So you can pull those in from a Git repo, get a nice sort of GitOps workflow here. They can pull directly from disk or like an S3 bucket. They can be pulled out of a database. It's a pluggable backend in terms of Cerbos. The advantage of using something like Git is it gives you a nice style GitOps workflow. With the Cerbos project, we also publish as part of the open source project CI tooling, so you can actually write tests against these policies and have a whole CI/CD pipeline set up around your authorization logic. But ultimately, somehow these policies loaded into that authorization service. So now that request comes in, this principal trying to do this action on this resource. The authorization service then evaluates the policies, comes up with a decision. In the most basic case, it's going to be allow or deny, but there's other examples where you may want to get back a query plan or a conditional kind of response. But ultimately, let's go with the simple allow deny decision. Now, the big advantage of having this centralized sort of authorization service, which is decoupled from the application code, is these services are going to make all the decisions. And so it's a central point where you can generate that audit log. So before that service returns that allow or deny, it can spit out to your logging infrastructure. At this time, this user tried to do this action on this resource, and it was either allowed or denied by this particular policy, with this particular Git hash, with this particular other request context. And so now that step we went through earlier around implementing audit logs is kind of eliminated because the audit logging is being done by the actual system that allows access, the authorizing service in this case. And those logs can be picked up and sent off to whatever you're using for log collection, Loki, Elastic, Datadog, whatever kind of is relevant to your architecture. But the key thing here is these are guaranteed to be generated, and they are guaranteed to be the same structure because they're being generated by the same system across your architecture. So that response goes back, and now in your application code, before where you might have had that big if-else style statement that we built, that now basically gets reduced down to a response to an API call or an SDK call. So you say to the system, can this user do this action on this resource? That call goes off, and what comes back is either an allow or deny. So your application code is now basically reduced to an if statement. Now, the benefits here are kind of twofold. I mentioned kind of the audit logs. You get that nice audit log benefits. But really, the main advantage of this model is now that your application code is implemented to whenever it wants to check permissions, rather than hard coding that logic, it just makes an API call out. The system behind the API call, the SDK call, can now change what that authorization logic needs to be without you having to touch this application code. And this is the whole concept of decoupled authorization as kind of a workflow or a architecture model or an industry as it is now, where the logic behind this system can change. So we went through what a policy looked like. When the business requirements change, rather than having to go back into your application code and sort of touching that big if statement like we had before, your application code doesn't need to change. What you're changing is those policy files. Those policy files can be tested in isolation to make sure they do what they want. And then when that policy change gets pushed, all your authorizing instances get updated. And now every part of your application is checking permissions via the authorization service is now going to get the updated response without you having to touch your application code, test your application code, or redeploy your application code. Your application is as it should be. And what's changing is the policy behind it. So there are some advantages and disadvantages of this model. Hopefully you've seen quite a few of the advantages up till now. So all this authorization logic is defined centrally in this approach. So it's decoupled out into a central store, a central policy repository. And those policies can evolve independently to your application code. So when you want to add a new role, add a new condition, you just ID those policy files. By using this kind of decoupled or sidecar microservice approach, it's completely agnostic to any particular language or framework or architecture that you're making. So you might have one service in Go, one service in Node, one in Java. As long as their permission checks are all being done by calling that authorization service that we modeled, your response is going to be a Boolean allow deny regardless. So it's completely agnostic to whether you're using a language or framework, even from an architecture point of view. As long as this authorization service is very lightweight, of which Cerbos is an example of one that is completely stateless, you can run it anywhere. So you can, if you're in Kubernetes, run it as a sidecar. If you're going fully serverless, you can run it as a Lambda or a Cloud Run Knative function. If you're doing edge compute, you can run it as like a WASM module on Cloudflare Workers or Lambda at Edge or these kind of technologies. Fly IO, for example, you could run it as another app inside of there. You can even run it on device. So pushing things down to the actual client for more presentational UI type decisions. We actually have one of the open source project users ship like physical hardware out in the world, ATM machines with Cerbos running on them. It's you're completely agnostic to any sort of architecture. As long as you can make an API call out from your service to the authorization service, you can integrate. With your logic now decoupled up of these static policies, it now fits into a very GitOps style workflow that I mentioned earlier. So these are versionable assets. You can have different branches of them. You can deploy different branches, different environments. You can set up your CI/CD pipeline, making sure you define all your tests for your policies. Don't allow a merge domain or production until those tests are passed. And then your authorizing service will pick up from that particular, say, production branch they're configured to. And so it's very friendly and kind of fits that model. And they're consistent audit trail, which is something that if you know you need, great. It's a godsend from day one. And if you don't think you need it now, I guarantee you will need it in 6 months' time for some spurious use case that you may not have had thought of yet. But having that consistent and clean audit trail just solves so many headaches down the line. Now, obviously, it's not all roses. There are a few things you need to consider to go with this approach. There ultimately is going to be another service, this authorization service that you need to run and deploy and scale. Thankfully, using things like Kubernetes and Sidecar's approach, the scaling is kind of handled for you. If you're in another approach, maybe something you have to think about. For some of these solutions, you do have to learn a new DSL for actually writing policies. With the Cerbos project, we stuck with YAML because we feel like love it or hate it. Everyone sort of knows YAML. And it fits very nicely if you're using things like Kubernetes already, and there's a very rich ecosystem of tooling out there that makes it easier to work with kind of YAML. And there's also going to be a new component in the critical path of request. But you're already hitting a database, you're probably already hitting your IDP, and we hope hopefully you kind of see some of the benefits outweigh the cons here of actually having to run this other component inside of your stack and give you kind of that consistent view. So that's everything I wanted to run through. I've mentioned Cerbos a few times. So Cerbos is a complete open source project that does this for you. You can find out more about this at cerbos.dev or hit us up on GitHub. We have users from small startups to multi-billion-dollar businesses, blockchain.com, Utility Warehouse, which is a utility provider here in the UK, multi-billion-dollar business. A slew of startups varying industries. If you're in particular like fintech or insurtech and medical tech, the self-hosted approach that Cerbos gives you is one that allows you to kind of move fast in these traditionally quite tough environments implementing. But also basically any startup, as you want to grow and scale and win those larger accounts and win those larger deals, you basically need this sort of system. And also a bit of a call to action. If you go to our website and join our Slack group and ping me a message, we have some nice swag and stickers and things that I can be more than happy to send you. And also we will be at World Congress, which was mentioned at the start. So we'll be there in Berlin. I'll be there as well. I'm happy to chat more if some of you are there. So that's it from me. I don't know if there are any questions. I haven't seen any pop up just yet. But you can find out more about Cerbos at cerbos.dev, and you can hit me up on Twitter, X, whatever it's called now. Or drop me an email if you want to speak more.
Hello again, Alex.
Hello.
Thank you for your awesome talk, and very happy to hear that you will join us on World Congress. So yeah, to the audience, if you want to meet Alex for a bit of a chit chat or more technical stuff, make sure to also join us. So Alex, we got some questions from the audience, and as we have some time left, I would say let's tackle them right away. So, and the first one would be, where do you make this authorization lists on? 3 network for transport or 7 application letter of the OSI model? And what do you think about combining all 3 layers for authorization for better SEC?
Great question. Yeah, so if I speak specifically about the Cerbos project, and then I'm going to touch upon kind of the wider ecosystem. When we started building out the Cerbos project, we were coming at this from an application builder or SaaS platform builder perspective. So we were always very much looking at, okay, what's the end user permissions, the if you're building a SaaS, what are your users or your users permissions need to be? There's some great tools and technologies out there, both open source and commercial, that really help you lock down the network layer and the transport layer. But we always felt there was kind of a lack of offering at the application layer. And so that's what we built out Cerbos particularly to solve, which is it's the layer where fully the end user's identity. You can go out to your database and fetch the entire record or resource that they're trying to access. And you also kind of define via your API what the actions are. And so the Cerbos project particularly is focused on solving just the application layer style permissions. If you go down to the other layers of the stack, there's some great tools. If you look at things like the service meshes out there, they'll sort out like MTLS between your services. Cerbos itself supports providing certificates as well to do MTLS between your app and the service or the authorizing service itself. And then the network layer, a lot of this is now kind of just built into kind of the network, the cloud infrastructure providers out there as well. So I think from a holistic architecture point of view, you do need to think about what is your security model at each of those layers, and pick ultimately the best tool for each of those. I don't think there's one really that can cover all of those, just because the different level of context that you need at different layers. As I said, Cerbos is particularly targeted the application layer, but you do need to make sure you have your T's crossed and your I's dotted when it comes to security at every layer of your stack. Leveraging, I always bias towards, if I'm choosing a security system or a security solution, don't build it yourself. Go and take either an open source project or commercial products, because behind that is going to be a team of people that spend all day, every day thinking about how to secure that particular part of your stack. And you as a system builder, you're focusing on really delivering the business value or the end product to your users, and you're most likely not going to be the expert in every part of those things you need. So you focus really on what your end value is and what your end customer needs to be, and pick solutions and plug in solutions into your architecture diagram. Can all be completely open source and free, or you go for commercial solutions, and to basically fill in your architecture to make sure you have security model from the wire up, as it were.
So yeah, don't let the security part be an afterthought. It's
Indeed.
Very, very important. Security management is no side hustle. Thank you for that answer, Alex. And I would say, as we got some more questions, let's tackle the next one. How can we ensure that authorization changes are always tested to prevent unexpected security issues?
Excellent question. Yeah, this is always this is what used to keep me up at night. This was always my fear around did we catch every edge case? Did we really understand, okay, what if we get like a malformed token? What if the token's not signed? What if we're getting some bad scope? What if we're going through like a migration and things aren't right, etc. So one of the things to always look for is when you're implementing any sort of solution, not just authorization, but is like, what is the testing and versioning capability of it? So we at Cerbos, I personally am a big fan of like the whole GitOps workflow. So you working on some assets, those assets are checked in, which means they're committed, you can sign those commits, etc. So you now have a bit of lineage of exactly what's going on. On the testing side of things as well, making sure you can actually test artifacts and assets before it goes anywhere near staging, production, etc. To make sure there's a good test framework. So in the case of Cerbos, as well as defining your policies and your which define, okay, for this action, this principal with this role could do this particular action, etc. You can also then define tests for them. So with the Cerbos approach, what you do is you basically define fixtures for your different users. So you'd have an example of an admin, example of a manager, example of a user, example of an employee, etc. All the sorts of different attributes and sort of the combinatorial matrix of what those attributes should be. You also then define example resources of the different types in your system. And then your tests are ultimately saying, okay, for this principal, for this resource, this action should be allowed, this should be denied, this should be conditional, this should be allowed, this should be denied, etc. And you basically fill out what probably came from the product or the business side of things, originally that matrix. Okay, this user should be able to do this should do this should only be able to do this under XYZ circumstance. And have that test suite almost defined first. You can actually do test-driven development for authorization, which up till now has been pretty nigh on impossible because it's been so coupled with your code. With a decoupled approach using Cerbos or one of the other solutions, you can test things before they go anywhere near environments and make sure things are up to date, and then follow your kind of best practices of like, okay, create a pull request, make sure my test pass. At the end of that pull request, let's sign that asset, let's merge it into the production branch, and then your production environment will pick up those those changes. So there's no way for a policy to get to that environment without going through the steps that you kind of define, and it follows the exact same process you would go through for application code changes as well. So the good processes, I'm sure you've already set up in your CI environment, and both from a developer but also like a infrastructure point of view, you can follow the exact same process when you use this kind of decoupled approach where the policies are static assets that are defined and then versioned and released that way.
I guess you could make a whole new talk just about the testing topic.
Yeah, if you're interested in it, I actually did a talk last week with the CNCF live stream about this exact topic. You can find that on YouTube somewhere.
Nice. Yeah, or maybe you could give it again at our next security day.
Love it.
Perfect. All right. Thank you for shedding some light on this also, Alex. And let's tackle the next question. What are some common signs that an application's authorization logic is becoming too complex?
I guess there's probably two ways of measuring this. Number one would be if you had to, when the requirement comes in, is how many engineers go, oh God, not this again, would be number one. Just the visceral reaction of hate you get maybe when you have to go and touch this code. And then maybe a bit more empirically is, if you go and make a permission change, how many lines of code are you touching? What is the diff that obviously lands? If you're getting into the point where a small change is resulting in hundreds, if not thousands of lines of code across your different repos and services, like that's going to be a point where you need to probably rethink this, and you probably already started envisaging some sort of solution to this anyway. And then the other way to kind of look at it is from the requirements point of thing. So I kind of went through that journey of like you're getting requirements from the sales team. We want to go and repackage our products. That comes in. You then have to go and do X number of weeks or months worth of work to go and support that. And then how often does that happen again? Are you going to be touching this code every 2 weeks, every 3 weeks, every month, every 6 months, every year? There's a bit of a factor here, which is like how dynamic or how versatile your sort of business side of things wants to be in terms of how they package your permission products. The moment that gets to a point where it's almost distracting from core product or feature development, that's generally a sign that you probably need to go and do this work once and for all. Because going back to kind of the before and after slide I showed of the code, once the API calls, the SDK calls are implemented, you generally never have to touch the application code again. All the changes are now being done inside of that policy without you having to go and touch all your different services and different changes. So it's a bit of a feeling from when you go, God, I don't want to touch this code again. Or it's a bit of more of a frequency type indicator that you need to go and maybe rethink how authorization is implemented today.
And as so many things, basically also dependent on your own experience.
Indeed. And I will say it's much easier to put this in early than retrofit it later. You can start very, very simple. You can just do incremental adoption, a couple of resource types at a time. Start with basic role-based access control checks. You don't need the more fancy permission-based stuff. And then your foundation is now solid, much like how your authentication provider, your identity layer would be set up once, most likely, and unlikely to be changed unless there's a big need for it. Doing the same with authorization early saves you all sorts of headaches down the line.
All right. Thanks, Alex. Let's tackle the next question. What are some benefits you see in decoupling authorization logic from the rest of the application code?
Yeah, I mean, so it's kind of the points I highlighted earlier around once it's decoupled out, you never have to touch that code path again inside the application side of things. It means that non-technical or people that aren't familiar with the particular language or framework that the application is using can actually kind of understand what the permission is if it's decoupled out. You're not having to know Java, know Go, know Node to really understand what the permission needs to be. Because really, if you look at where the requirements or the people that have an interest in authorization come from, it's most likely not going to be the developer that's implementing it. It's going to be coming from a product manager. It's going to come from a security team. It's going to come from maybe a customer team. These are people that aren't spending their day in your code base. They may not even know how to code, which is perfectly fine. But you want to have this kind of level of visibility of like how the authorization logic works. So decoupling it out into something, firstly, that's separate, meaning you don't have to touch your agent code, and then also into some sort of model or framework or language that more of the business or more of your team can understand, is a real benefit. And we have examples now where we've had chief information security officers come to us and say, thanks to having Cerbos, the engineering team putting Cerbos in place, I now can actually understand what our permission model is. Whilst before, I'd have to go and sit next to one of our developers and have them talk me through the code to understand what's happening. So it really is a bit of a leveling up in terms of who can understand what's going on. It massively reduces the maintenance and the churn and the context switching that developers have to go through and to re-update authorization. And then the third piece is really that audit story that I mentioned about. Now you have the centralized authorization service. You're going to get that consistent audit log, which is something you would have to do another implementation inside of your code base if you wanted to support. You kind of essentially get it for free by using a decoupled authorization approach, which is the central decision point, and those logs are generated in a standard format every time without fail, and can then be sent off to your infrastructure.
Right. Thanks, Alex. Next question. What solutions do you recommend if someone gets company credentials via SQL injection or social engineering?
Ooh, good question. So the credential piece is sort of, I would say, mostly, I'll caveat that, mostly upstream to authorization. So someone gains a credential, it's your identity provider or your authentication layer that is going to already do quite a lot around verifying that credential. So doing things like detection, if there's suddenly, you're now getting a request from an IP that there wasn't before, should that credential still be valid? This person was on a VPN and fell off, should that credential be valid? Things like 2FA, etc. come in. Where it intersects with the authorization piece is inside of your authorization policies. Let's say there's very sensitive actions or there's very sort of key things that you want to really be sure of the users who they say they are when it comes to allowing those requests. So for example, transfer money to our bank account is a classic one. So in your authorization layer, you now know who the user is. You're pretty certain this person who they say they are, but they may have maybe gained this credential in a way they shouldn't. What you're going to do in the authorization layer is reinforce things like a second factor or an MFA check for particular actions. So the way we kind of generally modeled this is when a request comes in, one of the attributes that comes to the authorization layer is the timestamp of the last second factor check occurred. And what you can do is have a policy that says, okay, if this, for the transfer action on a bank account, this action should only be allowed if that timestamp is within the last 10 minutes. And then you would have a response that goes back to your application saying, this application, this method is denied because of 2FA failure. And that would be a signal to your application to bounce that user off and go and force them to re-authenticate. And that's kind of a very simple, trivial example, but you can do much more intricate things around, re-verifying the token. If that token, with Cerbos, you can actually pass the key set to the Cerbos instance and have Cerbos verify the token as well as a second layer check. And then all the kind of best practices that you get from an authentication and sort of identity space kind of flow down naturally, because ultimately the request won't get to the authorization layer if the identity layer has determined that this credential or the person using this credential isn't who they say they are.
Thanks, Alex. We got another question for you. Are there any OSS tools or libraries you recommend for managing complex authorization requirements?
Yeah, I mean, so the one, as at the start, I work on Cerbos. Cerbos is an open source project that does exactly this. It's Apache 2 license. Go and grab it off GitHub. We have hundreds, if not thousands, of companies out there now using Cerbos for this exact use case. We built it from 10 years of having to build these systems ourselves and hated doing it. Now I spend all my time doing it. Cerbos is the off-the-shelf solution that manages these complex authorization logics for you. It's completely open source. If you're a developer or you have an SRE team that's happy to set up and deploy CI pipelines, etc., you never need to talk to us. You never need to give us a penny. Grab the code off GitHub. Enjoy your life. We also have like a managed control plane offering that sits on top, which if you want a bit more enterprise support, workflows, managed CID pipeline, etc., that's an optional paid product that sits on top. But the core of everything I spoke about today, all the features I spoke about today, are in the open source project. Apache 2 license, use it at will.
That's awesome, Alex. Thank you. Maybe as a closing question, I'm interested in your developer journey. Would you mind sharing a bit with us about how you became interested in tech in the first place and maybe some of the more important steps that brought you where you are now?
Great question. Yeah. So I'm a well, I'm a 90s kid. I was born in 1990, and so the early days of tech and the internet, and I was lucky that my dad particularly was in the early stages of IT, and so I always had computers around as a kid. And so I was about 7 or 8 when my dad sat me down and taught me BASIC on MS-DOS. And that's kind of where I started my coding journey in sort of 95, 96, 97, 98, that time frame. So I got into coding very early on. And one of the more interesting steps along my journey is I was about 12. And like every other 12-year-old boy at the time, or child at the time, I was reading the Harry Potter books. And I was also learning how to build websites and these kind of things, like front page, frame sets, that era. And I kind of combined the two together, and I built a Harry Potter fan site at the time. And that kind of grew massively out of proportion. So I went to the film sets, I went to the film premieres, I had writers working for me. So I had to learn and build and scale what was at this peak was getting about 3 million visitors a month. So I had to build a whole CMS. It was like a PHP backend. I had to scale a database. This was pre-cloud, so I was running like bare metal machines, racking up on my dad's credit card, server bills every month. At that point, I kind of got more into the tech than the content. So less interested in Harry Potter when I turned like 18. But I was like building and scaling systems. So it was always been a feature all through school, through university. I was like building websites for people and apps and doing like consulting here and there. So it's kind of natural that I ended up in a career in tech from the early age of 6, 7, when I was writing go-to print, etc. in basic MS Basic on a MS-DOS machine, way back. And then kind of went down the path of technical consultant for Microsoft, and then worked for numerous startups the whole time, still doing freelance work in my evenings and weekends in various tech stacks.
It's a beautiful story, Alex. Is the site accessible today?
It's not. It kind of went through a few evolutions. Sort of when the whole Harry Potter craze died down, I kind of pivoted into more like a general film and TV kind of review site, which is no longer around. But if you stick my name into YouTube, you can find sort of a 15-year-old me with my voice breaking halfway through interviews. If you want to laugh.
Oh yeah, well, let's research this afterwards. No, and I'm very happy that Harry Potter is something that kickstarted your career. So.
Indeed.
All right. So, Alex, sadly, we ran out of time, but it was a pleasure having you today. Thank you so much for shedding light on this very important topic. And yeah, hopefully we see each other again on another live day or at World Congress.
Thank you very much. Take care, everyone. Have a good day.
Thanks, Alex. Bye-bye. All right, and we jump to the next speaker of the day. He's web scraping anti-ban expert at Wiremind. He's the creator of Scrapoxy. He already spoke at various conferences, and with over a decade of experience in the field, he certainly knows what he's talking about. Very welcome, Fabian.
Hi, nice to meet you.
Hi, yeah. So happy that you joined us today. I hope everything is all right on your side.
Yeah, it's perfect. Thank you very much to have me in the conference.
Awesome. Yeah, pleasure is all on our side. So, Fabian, before we start with your talk, would you mind sharing a bit with us about what we're going to learn from you today?
Yes, I will speak about antibot systems. So, the sneaky stuff that you have on the website that block you and avoid you to collect data when you want to start a business. Also, how they're working and what are the techniques to bypass them.
Awesome. Sounds like a very fitting topic for today's Security Day. And yeah, without further ado, I would say the stage is all yours, Fabian.
Thank you very much. So, so I'm Fabien, Fabien Vauchelles, and I've been deeply passionate about web scraping for years. So my enthusiasm led me to explore the fascinating world of proxy and antibot systems. I work, as you say, at Wiremind. It's an amazing company specializing in revenue management within the transportation industries. And our work at Wiremind involves handling millions of prices on a daily basis, which requires substantial investment in web scraping technologies. Our setup for data collection is pretty big and many built on open source techs. So I'm also the creator of Scraproxy. Scraproxy is a free and open source proxy waterfall proxy aggregators. It's allow you to manage and route traffic through cloud provider and proxy services. It supports major cloud providers such as AWS, Azure, GCP, or DigitalOcean. And also it supports proxy services like Brightdata, Raybyte, IPRail, and many others. And since I started in February 2024, over 200 users have installed Scraproxy. They exchange 70 terabytes of data, receive 1 billion requests, and use 1 million proxies. And before we dive into our discussion, I'd like to share with you a little story. So, a decade ago, I found myself in a conversation with a friend who worked in the HR industry. This was a time when AI and NLP technologies were just at the beginnings. During our conversations, we stumbled upon an idea. It is always challenging to identify potential candidates in the IT industry. So we wondered, what if we could predict if someone might leave the job within the next 2 or 3 months? This way, we could reach out to them and offer them exciting job opportunities. It's unlike a brilliant concept on papers, but as you probably know, machine learning algorithms need large amount of data to train. And to do that, we need profiles, millions of profiles. So we thought, okay, let's go and gather them. And the real challenge came when we tried to collect hundreds or even thousands of profiles. I hit a wall. I was new to web scrapings. I checked on Stack Overflow for solutions, and the advice was to use proxies. But proxies were very expensive at these times. My idea was to buy a virtual machine on Amazon and install a script proxy to have a new, fresh IP address. It worked a little bit, but I faced the same issue, always blocked. So how can I get many fresh IP addresses at the same time? The answer came into the form of a basic script. By destroying, creating, and automatically installing new virtual machines, the IP address will change. And this was the birth of the Scraproxy project. But my journey has just begun. Using virtual machines from cloud provider didn't avoid me from being blocked. And at this point of time, there was something I didn't understand, something known as the Turing test. Let's explore another example. When we purchase a flight ticket to go to a conference, it seems like, hey, I'm a human living in Paris, and I'm so excited to go to this conference. I'm buying a round-trip ticket during the evenings, using Safari on Mac, and I use a DSL or fiber connections. These interactions reflect a natural and organic behaviors. However, when it comes to web scraping, it often takes a different form. It's more, hey, I'm scraping, living in a data center in Highland. I'm not interested to travel anywhere else. My goal is to retrieve thousand prices from many airlines. I'm accessing to data with a deep link at 2 a.m. using a Python library within my Dockers. My internet provider is AWS, and I love to randomize my user agent to seem the human. Honestly, this behavior doesn't seem to be organic. And the website understands that, and also the antibot system. So you see, they are conducting Turing tests on your behalf. So the question is, how do antibot systems assess us? They meticulously check our browser stack, analyzing each signals. Starting with our IP address, they know where we are coming from. The protocol headers divulge details about our operating system, the browser's versions, and they execute JavaScript to get system and browser configurations. And also, they track our navigation pattern like the sequence of web pages and even the sequence of events such as mouse movements. And they cross-reference all these signals to validate the consistency. So now let's dive into the layers of the browser stack. The initial layer is the IP address layers. It is the very first piece of information a website obtains when we establish connections. An IP address is a gold mine of information. Are we connecting from an internet box? Are we connecting from a mobile phone? Are we connecting from a data center? For instance, if we are purchasing a ticket from Paris to New York, is our connection originating from India? Is there any inconsistency such as having a US IP address while our browser time zone setting is in Europe? All these signals flags you. Moving to the second layer, let's understand the power of protocol headers. In this part, we can distinguish three protocols: the TCP protocol, the TLS protocol, and the HTTP2 protocols. First up is the HTTP protocols. The RFC describes how operating systems should implement the TCP protocols. But in practice, the implementation often varies not only from one operating system to another, but even between the different versions of the same operating systems. And by examining TCP headers, it is possible to statistically deduce which operating system is responsible for sending the packets. Second up is the TLS protocols. The Transport Layer Security Protocol is an encryption protocol on top of the TCP protocol, and it's used everywhere. Here is an overview of how it's working. When a web browser creates secure connections, it initiates a negotiation with the website. This negotiation is called handshake protocols. During this process, the browser sends a client hello message. This message includes a list of supported encryption algorithms such as DSA, RSA, and also some options. It is called the cipher suite. The server selects the most secure and compatible algorithm from the list and initiates a key exchange. And after, they exchange data, the key can change, etc. This is where the magic unfolds. Each browser version has its unique cipher suite and options. This leads to the creation of a TLS fingerprint, and it is called the JS3 fingerprint. It was invented by Salesforce. So with this fingerprint, the server can identify which library or browser is. Is it Chrome? Is it Firefox? Is it Edge? Is it a Go library? Is it a Python library? Or is it Node.js library? So it can flag automation systems. And the third protocol is the HTTP2 protocols. HTTP2 headers resemble to TCP headers. Browser implementation introduce variation on settings, priority flags, field order, etc. And by examining HTTP2 headers, it is possible to deduce which browser is responsible for sending the packets. So now I think you know where I'm heading with this. Imagine this. We claim to use a Firefox browser on Windows, but the browser stack suggests we are coming from Linux with Chrome. Of course, it's a red flag, and it could lead to a ban. And it doesn't end here. Also, if we look to the HTTP protocols, we can fingerprint the HTTP headers. Here is a small code from a well-known antibot system for Node.js servers. The code is public on internet, you can find that. It's just 4 lines of code, but it's bulletproof. This tiny function gets the list and order of headers. When we develop a scrapers, we often try to reduce the number of headers to the bare minimums. We strip away as many headers as possible to create a simple and maintainable payloads. However, when you read these functions, you realize that all headers are crucial. Even they are not essential for the APIs, they are vital for the fingerprint process. And this function can block most of the scrapers. Of course, all browsers can execute JavaScript. It is truly astonishing how much information they can extract from JavaScript. They can get detail like our time zone, the GPU model, the GPU fingerprint to check the consistency with the GPU models. They can get the number of speakers, the speaker model, the microphone status. They can get the webcam battery level, so they know if we are a smartphone or a laptop. They can get the list of font installed, the list of browser extensions, the plugin installed. They can get the adblock settings. They can get the real IP address if you are disclosing that with a WebRTC leak. They can get the screen size, blah, 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 everything. And if you are using a smartphone with Android applications, they can know if Android debug is activated. They can know our device architecture. Do we have ARM architecture? Because most of emulators run on Intel architecture and they can detect reverse engineering. They can get also the Android version, the smartphone model, and the unique install ID of our mobile, so they can track us everywhere. And it's not finished. As you probably understand, they can track also our action, how we act on a website. Antibot system observes the sequence of web pages we visit. Do we initiate our journey with a search query, or do we access data with a specific deep link? Are we loading JavaScript and executing JavaScript and loading CSS, or are we only fetching HTML? Furthermore, they can track the timing of our actions, the interval between web pages. They can get the delay between mouse clicks. They check also mouse movement because human tends to move the mouse in a natural, fluid manner, often resembling to a basic curve, as opposite to a straight line movements. And all this information are transmitted to the web server at intervals. That's why sometimes we navigate smoothly a website, successfully completing several requests, and suddenly you get a CAPTCHA. This happens because our reputation score gradually reduces over time and go below thresholds. And all these signals are combined together to get a binary classification score. Algorithms blend everything and use machine learning techniques to rate the browser sessions. And to improve and adapt over time, they can use reinforcement learning algorithms like GetBoost. Yeah, if we examine the previous stack, it becomes evident that attempting to outsmart the Turing test is a huge challenge. However, there is a vulnerability in the systems, and this weakness is known as a false positive. So let me share with you a personal examples. Last year, I needed to purchase some train ticket online. So when I connected from my laptop, which I never use for scraping, and my IP address too, I just got a message stating, "You are a bot." Honestly, it took me by surprise. They just detected that I use Linux, in fact. But never mind. I simply switched to a competitor website. It was a false positive, and it happens all the times. Websites raise too much their security level and deny accesses to customers, and they lose customers. So they need to lower the restriction at the ends. So if we are running a business, false positives are something that you want to avoid at all costs. An antibot system must adapt and minimize the false positives. And if you already did a little bit of data science, you already know the two approaches, the two possible approaches. The first one, if you want to use all available signals, it requires to collect a massive volume of data, millions of clean records for each signal, clean tagged records for each signals. It is too challenging, too expensive, and you cannot do that. So what you are doing, in fact, is restricting the number of signals. You just collect and focus on the effective ones. Furthermore, there is some signals which are very difficult to access, like the protocol headers, because you are not root on the machines, you cannot use Kubernetes or Dockers, so it can be difficult. Nowadays, commercial protection track between 100 and 200 signals. So basically, most of the time, antibot systems rely on IP information, HTTP headers, JavaScript execution, and behavior trackings. And they start to also track TLS fingerprint. So now our objective is to understand which signals are used by an antibot commercial and which protection is. So to do that, we can rely on a browser extension named Wapalizers. This extension is amazing. It provides us all the technology of a website, including the security technology. And we can also confirm the information with the Chrome DevTool and the network inspectors. If you are looking to the request, you will find some strange or creepy requests. It's normally the antibots. Everything is encrypted. You can find encrypted cookie and many stuff inside. If you are using mobile applications, you can rely on interceptors such as SharpProxy, HTTP Toolkit, Burp tool suites. There is many. And furthermore, when we deal with antibot systems, it is easier to analyze Android applications because it's Java. And we can decompile the Java source code using tools like JDX and also perform some injections on the code live. And this is very useful because it enables us to understand how some fields are generated and used, especially the ID in requests, which pop up from nowhere. So now let's understand the architecture of an antibot systems. It's an example. You have three elements. First, you have the browser. Second, you have the website. And third, you have the antibots. So when we connect to a website, our browser also connects to the antibot URLs. This URL may be hosted on the website or on a separate antibot servers. First, with JavaScript, the website gathers a lot of data about a browser and device like configurations, events, mouse movement, etc. Second, the payload is encrypted and sent to the antibot URLs. In return, the antibot system issues cookies that is linked to our sessions. And this process is repeated at regular intervals to monitor the sessions. Now, when we access to the website, so not the antibot URLs, we send this cookie along with our request. And the website initiates a server-to-server request to the antibot system to retrieve a reputation score. And based on this score, based on the thresholds, the website makes a decision to either grant or deny us access. So now let's focus on the payload. So if we have a closer look how the antibot system secure the payload. There is many methods for payload encryptions, from simple base64 encoding to asymmetric encryptions. Now I will focus on the most advanced techniques, asymmetric encryptions. So first, the antibot with obfuscated code collects a lot of the data on the browser, the configurations, the events. This data is then structured into a JSON with internal keys to make it more challenging to interpret, so it's not obvious key. So second, the obfuscated code of the antibot system on the browser use RSA asymmetric encryptions. The public key is integrated into the antibot code in an obfuscated way. Now, the encrypted payload is sent to the server through a post request. Third, the server decrypts the cipher using its private key. Since the server holds the private key exclusively, it is impossible to decrypt the payload directly. So, as we saw, it is difficult to handle an antibot systems. Now we need a methodology for constructing scrapers, because website and protection quickly evolve. Additionally, it is important to note that not all websites are equally protected. Some websites have no protection, some websites have very small protection, some websites have very difficult protections. And using the same approach for every website can become costly and time-consuming. So we need an incremental methodology to adjust our strategy and cost. So let me share with you a possible methodology, a generic methodology. So imagine that you already have a scraper. You perhaps use Scrapy, the well-known Python framework for web scraping. The scraper, the spider, is already developed, but it's not working. Perhaps it's time to tune the parameters. So you can modify the delay between requests, the number of concurrent requests. You can change the HTTP header according to the user agent. You can also change the referrer, if you are using cookie or not, the TLS version. Do you use the latest TLS versions? You can change also the payload or the order of request. Okay. Perhaps now it's not working. And first reason is because we are only using the same IP address, which is a server IP address. So we need to introduce the concept of proxy. So proxy is a system which relays your request to the web servers. So instead of sending one IP address sending millions of requests, the server will see many IP addresses sending a few requests. We can start with different type of proxy, and the first one is data center proxy. So they are fast, cheap, and reliable. It's like installing a virtual machine on the data centers. And to correctly orchestrate our strategy, we can use layer script proxy. So you install script proxy in your infrastructures, and you are something that will manage everything, every proxy, and create for you a data center proxy pool. Now, if it's not working, it's perhaps because we don't act like a browser. So we need to introduce the concept of headless browsers. So what is it? It's a browser which can run inside the Dockers. So you can do the automation in the Dockers. There is many frameworks to do that. There is Selenium, Puppeteer, Playwright, and a bunch of plugins to skip the JavaScript fingerprint. Now, if it's not working, it's perhaps we are using very basic proxy. So it's time to introduce more advanced proxy. There is different type of proxies. There is ISP proxy, residential proxy, mobile proxy, hardware proxy. So first type of proxy is ISP proxy. It's kind of data center proxy, so it's virtual machine installed on data center, but they don't use the IP address from the data center. Instead, they will rent IP address from mobile carrier or internet providers. So you can rent this kind of IP range for a lot of money, of course, but you will be mixed with real users. The next type of proxy is residential proxy. So how it's working? So it's very easy. You can share your bandwidth, your laptop bandwidth, your mobile bandwidth with applications, and you will get money for that. And that's where the residential proxy come from. So if you are using residential proxy, it is a real IP address from a human, and perhaps 10 minutes before, he just go to famous e-commerce websites or social networks. So it's a clean IP address. And there is also mobile proxy. So mobile proxy provider has a ton of 4G keys in front of the antenna, and they will rent you the IP address or perhaps the whole 4G key for that. And you can do the same in your office with other proxy. So you install the material and you are install the 4G keys, and you've got your personal mobile provider for that. So there is a lot of type of proxy to do that. And Scraproxy, of course, will manage that very efficiently. It just 2 clicks to add providers. You don't have any code for that. And now, if it's not working, it's perhaps because automations is detected. So we need to switch to a more advanced strategy and introduce headful browsers. So it's like running a real Chrome or real Firefox inside your Dockers, but you need to build that yourself. You can use open source solutions for that. You can use commercial solutions. Both are efficient. You can choose whatever you want. And if everything is not working, there is what we call unblocker APIs. It's full commercial solutions, but they will do all the previous steps for you. You will pay for that, but they will use machine learning techniques to adapt the parameter depending on the targeted websites, and it can be very efficient. And on top of that, you can add also CAPTCHA solvers, because sometimes you need to solve CAPTCHA. For that, there are AI CAPTCHA solvers. They are very fast and clearly more ethic than using human CAPTCHA solving farms, which are not very good, to be honest. Don't use them. Please use AI CAPTCHA solver. They solve CAPTCHA in 2 or 3 seconds. Okay. So now, if we translate the previous methodology into an architecture schema, it would look like this. So first, we build a scrapers. It collects information from all around the world. Second, as we grow, we need a better organizations. We will set up a place to store all the collected data, of course, and also the URL frontier. The URL frontier is a list of URL already visited or item already visited and the URLs to visit. This means we will introduce 2 important tools, a database and an orchestrator. And in addition, we often use a broker to distribute the tasks, such as RabbitMQ. Second, we realize that using just one IP address is not enough. So we need to add proxies. We add the Scraproxy layer to correctly manage all these proxies. It is cool because it comes by default with cloud providers like AWS, Azure, and GCP. And guess what? These cloud providers often give massive free credit for startups. So it's a good start to create your own private proxy pool. But as we see, sometimes, even with new IP addresses, things don't go smoothly. So we need to add different type of proxy like ISP proxy, residential proxy, or mobile proxy. Of course, Craproxy will handle multiple providers smoothly and you don't have to code anything. And we learned also we need to execute JavaScript and introduce headless browsers. But rather relying on a single browser, we create a browser farm with Chrome, Firefox, Edge, and many operating systems. And this is the most tricky part because there is no existing tool on the market to do the jobs. So you have to write it out on your own. Okay, so with this infrastructure, now we're ready to scrap the web. But I didn't disclose you the whole truth. The web is basically divided in two website categories. 80% of the website drive only half internet traffic. The remaining 20% drives the other half. And we are talking about major e-commerce website or social platform here. Because this website receives a lot of traffic, they integrate the most advanced commercial protections. And our previous approach won't fully work and the success rate will be a little bit low. So this time, we need to identify precisely which signals they are monitoring and emulate them. So if you remember the antibot architecture we discussed earlier, the signals are embedded in the payloads. So yet the payload is encrypted, making it impossible to intercept directly with Chrome DevTool or man-in-the-middle techniques. So we must trace back to the payload generation process. And the payload is generated within the browser code of the antibot systems. However, the code is obfuscated. So what is obfuscations? Obfuscations is the art of rendering code incomprehensible. We all have that one colleague who excels at making their code unreadable, and perhaps it's even ourselves. However, here, what I'm talking about is taking that to a whole new levels. When code is obfuscating, it is impossible to decipher what it's doing or why it's working. So now, deobfuscation is the process of making sense of obfuscated code. It's not a simple mirror operation because it can be very challenging. However, when we are able to understand obfuscated code, it is a giant step. And to understand the obfuscation, first, we must understand obfuscation methods. So let's walk into some techniques about string obfuscation and code for obfuscations. So to start, we can use a tool called Babel.js. If you are doing front-end developments, you're probably familiar with Babel. It is used for minifying the code. So what does Babel do exactly? It takes a string, which is basically your source code, and converts it into an abstract syntax tree, an AST, using a parser. This tree represents every operations within your source code, such as function declarations or expressions. Then we apply transformation to this tree, like modifying node settings or swapping branches. And clearly, applying transformation to this tree structure is much simpler and much more intuitive than on text, believe me. And finally, we use a generator to convert our tree back into source code, which is obfuscated or deobfuscated. So let's take a look at some string operations, starting with the string bracketings. In many interpreted languages, you can access methods and values using object keys. This key can be transformed from dot notation to string notations. But as you see, it stays readable. That's why we need to make it more harder. So it comes a bit harder to read with string splittings. It's like breaking a word like screen into SCR and EES. It is harder to read, but you can still understand what the code is doing. So how can we make it harder to understand? So let's try constant unfolding. Instead of using strings, we will use random constant grouped in different places in the code. So when you read the last line in red, you cannot understand the meaning of the operations. But clearly, we can still refer to the definitions to figure out the actual value. That's why we will encrypt the value using functions. And this technique is known as string concealing. In this example, I use a basic base64 encoding. But keep in mind that antibot systems use much more advanced encryption function and multiple functions combined everywhere. This makes it harder to get the original value. So now let's jump into code flow obfuscations. The first technique is code flow confusions. The goal is to exploit all the possibility of the JavaScript interpreters. Here, we can alter the conditions. Normally, if the conditions is evaluated to true, the interpreter will execute the code block after. However, we can transform this into a condition without a condition block. It is more complex, clearly, but yes, we can still read it. So we will inject that code. And this code doesn't do anything and is practically never executed, but it makes sure understanding the script is harder. Here, both expressions give the same result, 10. However, it's clearly harder to understand. So imagine if we have this with the previous conditions, it would make things very difficult to figure out. And of course, antibot system will make far bigger sentence of that code. The next thing that we can combine with is scope confusions. The idea here is very simple. Just name everything A, including variables, classes, or methods. And if there is some scope collisions, we can use B, perhaps C, and so on. So in this example, we can change valid to B. However, there is another B within the code blocks, which is a constant. So which B are we referring in the blocks? It can be pretty confusing. And I love the last one. It is probably the sneakiest method out there. So what is exactly control flattening, control flow flattening? The objective here is to convert sequential code into a state machines. It's like adding go-to point in your code. So you will end up with a single state machine for all your block codes. And it turns debugging into a nightmare. You cannot follow anymore the instructions sequentially. Okay. So now I won't go into detail about the obfuscations, but things that you should know, you need to determine the sequence of techniques that you use, and you should try one and others until you find the right approach and chainings. So now, let's say we successfully deobfuscated the code. We need to identify the signal added to the payload. And there is 5 types of signals. The first set of signals are about configuration details. These include browser settings, OS characteristics, event, and more. We already discussed that previously. So let's jump to the second step. The second step of signal is about automation detection this time. Tools like Selenium or Brave browsers introduce their own JavaScript objects for interactions. And antibot systems love to check these flags because it's a red flag for automated activities. The third set of signals focus on graphic rendering these times. This involves drawing graphics on a hidden canvas to create a unique fingerprint of the rendering. And it is important to note that rendering depends on three factors. First, the browsers. Second, the operating system. And third, the GPU. For example, emojis rendered on Windows and Linux can look quite different. Additionally, switching between GPU and CPU rendering on the same browser and same operating system will also produce a different hashes. So if you check consistency between the declared GPU and the real hash, you can be surprised. The fourth set of signals try to counteract reverse engineerings. A common technique in JavaScript is to get the code of a native functions. If you print the code of a query selector, so you're not executing query selector, but getting the toString part, you will receive a native code as a response. And however, if you monkey patch the functions, which is typically when you're using polyfills, the result changes. Native code no longer appears in the response. And this is how antibot system detects that you are trying to emulate some behaviors. And the last set of signal is integrity control. They simply add checksum everywhere using simple or complex functions. So if you attempt to modify a value, don't forget this time about the checksum. It's very important. So that's all about all the signals. Now, I also wanted to spotlight what's coming next in terms of protections. So these are techniques that you will come across in the next coming months. So now, when you are trying to understand antibot protection code, you usually start with obfuscated code. You try to deobfuscate code and to go up to the source code. So what they are doing now, advanced antibot system adds another layer, a JavaScript virtual machines. It is similar to the Java virtual machine, the JVM. The virtual machine executes bytecode. But this time, the bytecode is proprietary and clearly undocumented for purpose. So translating from the bytecode and going up to the original source code is now a very, very difficult challenge. So I hope you enjoy the sessions. So I would like to share with you some open source tools that can be very useful when you want to understand antibot systems. So thank you very much. Download Scrapboxy if you want to join my company, and I will be very happy to answer some questions.
Hello again. Thank you for the talk and awesome, cool design slides, if I might say.
Thank you very much.
I can see that a lot of effort flow into this. So thank you for that also. And yeah, good that you mentioned the questions because we got some, and I would say let's tackle them right away. So, first one. What if we use some VPN tool and switch our IP address and do some web scraping?
Yes, that's a good question. You can do that. But the question is, how many IP addresses do you want to have? Imagine that you have a rate limit on the website. You can do 10 requests by IP address. Okay. If you want to do 100 requests, you will need 10 IP address. So it's the same for the VPN. But here we are not talking about having 100 requests. We are talking about sending millions of requests. So you cannot switch and have perhaps 1,000 VPN subscription. It can be very expensive. So the solution perhaps is to register to providers or to use data center IP address to solve this issue. And there is another thing that VPN are tagged, and the IP address of the VPN are known by the antibot system. So if you are using a VPN, you can be easily blocked.
All right, makes sense. Thanks for answering this. And let's tackle the next one. When we do web scraping, some forum or Twitter, for example, will it slow that system? And is it illegal? And can their IDS detect our behavior?
Oh, yeah, I love this one. And thank you for asking. All the questions are good, by the way. So multiple questions in this one. The legal, the detections. So let's jump to the legal parts. So basically, the first thing that you should avoid is doing a denial of service, a distributed denial of service. We are not talking about scraping. We are talking about a legal issue and killing the website in front of you. So that's things that you don't want to do. So it's very important when you are doing web scraping to monitor the response times. Is it increasing? If it's increasing when you are adding more concurrent requests, you are slowing the website in front of you and you can be close to a denial of service. So you should track this information very closely because it's clearly a legal part and you can go to jail for that. So after that, it's more a commercial position and commercial debate and on is it legit or not. So first, you should think, am I getting personal data? In Europe, you have the GDPR, and other countries you have other law. But if you are collecting personal data, you cannot do that without the agreement of the users. And of course, you won't have the agreement. So forget to collect personal data. But if you are not collecting personal data like prices, object descriptions, places, whatever, there is a new questions. Are you using the login? So did you sign the term and conditions? Basically, when you are signing to do the web scraping, you have created an account and you agreed on the term and conditions. And 100% sure that web scraping is forbidden. So you are breaking the rule. But if you are not doing the login and you are getting the public data, you didn't agree to the conditions. And there is a recent use case, Bright Data versus Meta, and Bright Data win. It's a proxy providers, and they win because they didn't broke the term and condition, and they just collect public data. So yes, if you are not doing a denial of service, if you are not collecting public personal data, and if it's only public data, you can do your business with that.
Right. Thank you. Next question. What are the common signs that a website or application is under a bot attack, and how should an organization respond?
It's more on the other side. I'm collecting data. And in this game of collecting data is not to being caught. So yeah, not sending too much requests. Yeah, but I'm not going on the other part where you are detected. How antibot system or how they detect it's not attack, it's collecting. Sometimes it's denial of service, but it's other equipments, other software to detect this kind of attacks. There is a lot of security provider who are providing anti-denial, distributed denial of service. But about collecting data, clearly they analyze the fingerprint and all the stuff I presented. And how organizations should respond, it depends on what you want to do. You can block the sessions, you can send a captcha to check users, whatever.
Okay, thank you. We got another question. What kind of training or background is recommended for someone looking to specialize in anti-bot system development?
Yeah, so a lot of questions on not scraping, but how to protect the website. That's a good point. And it's very fun because I'm discussing a lot with guys and following them who are building the anti-bot systems. So first, you should understand how the network stack is built. because there is fingerprint on TCP, TLS, so you should be comfortable with the OSI layers and how it's working. And after, on executions, you should be also comfortable with obfuscations. If you are building an antibot system and you want to hide the code, you should be able to reverse engineering the code and to assure that it's very difficult to reverse engineering. So the first things to do is to check that no one can read your code. So you must be comfortable on both sides. You should know how to analyze the systems and to show what system exists in the world, so you can have idea on that. And clearly, you should be comfortable on how to encrypt your systems.
Yeah, good point, of course. So, thank you. Next question, let's take this one. This is really the cat and mouse game. How do these anti-bot systems adapt to evolving bot tactics? How frequently are they updated?
I love your questions. That's very good ones. Yes, that's the cat and mouse games. And what I can say, it will never end. And that's why there will be always a job on both sides. I know a guy's a CTO of an antibots company who says we are all playing to the same games, but on different sides. Yes. So it will never stop. And to give you some hints about the frequencies, some antibot systems are updated every month, and you see updates, new signal added every month. Some are updating every 3 months. And when it comes to Android applications, it depends how it's built, because you cannot release for the user a new version every time, and you cannot release a new Android application and ask to the user to come and to download the new versions. So it depends, but between 1 month and 3 months. And yes, you have to study the new techniques. You have to understand which are the tricks. What I presented is the latest tricks, but I think in 6 months it will be new.
You always need to be on track and adapt.
Yeah.
So thank you. Next question. How do you manage rate limits and prevent being blacklisted when scraping websites for data?
Yes. So in this part, I assume that you already have set some proxy. Okay, the question is how much request can I send to one proxy before it is blacklisted? That's something that you can monitor with a success rate. So the success rate is, do I correctly collect the data or do I not? That's how you calculate the success rate. And you check by adding increasing the number of requests if your success rate is just going down. And that's how you track the rate limit. And I said previously that you can perhaps send on one IP address 10 requests, and after your blacklist, okay, you have to check that. Is it 10? Is it 20? Is it 30? After, you have your answer. So if you have 100 requests to send, depending on the rate limit, you have 10 proxy, 20 proxy, 100 proxy. I don't know. You have to adapt to the website in front of you.
Yeah. Makes sense. All right. And one more question. How do mobile apps differ from websites in terms of anti-bot defenses?
There is different approach for the mobile, because a website, you have HTML, JavaScript execution, CSS, you have everything. You have the graphics, the structure that you download. On the website, you are only doing AJAX requests, so it's only pure data. So you are only calling the API, but it could be close if you have Angular applications, React applications to that. So now they are focusing on the API, but with the API, you can get a lot of data. You can collect all the HTTP fingerprints, the TCP fingerprint, so you can know if it's coming from an Android or a Windows. So it can be strange to have someone trying to collect data from an API, which normally it's an Android signatures with perhaps a Chrome signatures. So it can be tricky on this part. And in addition, you can collect a lot of informations with Android. I show you can collect the unique install ID, if Android debug is activated, the build version, etc. There is perhaps of 20 signals specific to Android that you can collect and send to the antibots. And it adds difficulty to bypass these protections.
Yes. All right. Thank you so much. So maybe as a closing question also to you, would you mind sharing a bit with us how you became interested in tech in the first place, and how did you get to the point where you are now?
Yeah, it's a long path. I started to develop when I was 6 by copy paste what I've got on a book in a basic in the basic language. After I learned Pascal, Perl languages, going to the web, and I'm not a guy interested in video games. I'm clearly interested what's about on the network stack. So I already want to invest time on that. And the web scraping, the antibot system is very, very interested. Also, there is not a lot of people investing time on this area, in this niche. So it's very interesting to discuss with this small community.
Awesome. Thanks for sharing. So yeah, also an early bloomer when it comes to programming. All right.
Thank you a lot.
Yeah. Fabien, thank you so much for joining us today and shedding some light on these topics. It was a pleasure having you, and hopefully we see each other again on another live day.
Thanks a lot. See you. Bye-bye.
Thank you. See ya. Bye. All right. And we jump right to the next speaker of the day. He is Senior Information Security Consultant at SBA Research. His consulting focuses more on the technical aspects of information security. He also frequently conducts penetration tests on various computer systems, and he's also one of the organizers of Sec4Dev, which is a security conference for developers from SBA Research. Very welcome, Michael.
Well, hello. Thanks for the introduction.
Yeah, thank you so much for joining, Michael. Pleasure to have you again. So, before we jump into your talk, would you mind sharing a bit with us what we're going to learn from you today?
Sure. I will show you how you can embed business rules and security properties into the type system that your programming languages provide to you, and how you can prevent mistakes and vulnerabilities by design.
Awesome. Sounds like a very fitting talk for our security day. So, Michael, I don't want to steal any more of your speaking time. The stage is all yours.
Thank you very much. So, hi, everyone. I hope that you enjoyed the security day so far. Today, I will tell you a bit about the power of strong type systems. I will show you examples how to structure your applications in a way that some vulnerabilities are not possible anymore. I hope you're not afraid of code snippets in languages that you don't know, because you will probably see a couple of them in this talk. But fear not, I will explain everything you need to know as we go along. Who am I? I'm Michael Koppmann, security consultant at SBA Research, one of the largest research centers in Austria focusing on cybersecurity. In my day job, I do penetration tests for the web, mobile applications, and more. I'm also doing projects like social engineering attacks, source code audits, architecture reviews, security trainings, and much more. I'm also leading some software projects that we have in-house. So I'm also a software developer like you. During my work, I see a lot of code of questionable quality. The same mistakes are repeated over and over again. So I started on a quest to find methods and techniques to prevent these mistakes by design. The whole idea for this talk came up when I learned about domain-driven design. the term was originally coined by Eric Evans in this book. You may have heard about it. It's also known as the Blue Book. Guess why? It was written almost 20 years ago, but many of its wisdoms are still relevant today. The core ideas of domain-driven design are that your code and its structure should match your business domain. It teaches you to focus on your core business logic and how to design your program so that technical details stay abstract and can be easily replaced. While collaborating with the domain experts in your company, you develop an ubiquitous language that every person involved in the project can understand. So no abstract singleton proxy bean factories allowed. Many of its concepts got popular over time. You probably know some of them. Entities are objects with an identity and a life cycle. Value objects contain pure data, are immutable, and are without behavior. Aggregates protect invariants across multiple entities. So, in a web shop application, a product ID could be a value object, a product could then be an entity, and the shopping cart could be the aggregate that manages the overall state, like the total price of all products. Bounded contexts are logical components your application is made of. These are good candidates when choosing how to slice your application in microservices, for example. And repositories help in avoiding polluting your business domain with technical details for persistence. Now, let's add types to the equation. Object-oriented programming combines data and functions into classes. But classes are mainly used to separate responsibilities and should help in improving the maintainability of your code. The idea that types or classes can be used to encode business rules is rather new. There's this catchphrase, make illegal state unrepresentable. This means that you design your data types in a way that invalid combinations or states cannot even be expressed. So let's imagine that you have a configurator with 3 settings, and you could implement it with 3 Boolean flags, right? But you also know that some combinations simply do not work. If option B depends on option A, it shouldn't be possible to set B but not A. But the Boolean flag design does not prevent that. So you have to write runtime checks for that, write unit tests that should cover all possible combinations, and so on. And that's a source of error we want to avoid. We can further build on this and even prevent certain security vulnerabilities by enforcing specially constructed values as inputs. You will see examples for that later. It's beneficial that you use immutability and immutable values for most of these techniques. That way, you only have to perform validation logic once when creating the value. And if you design your application in a way that does not allow invalid state and input, your compiler will prevent you from accidentally doing the wrong things. You don't need to write runtime checks, and you don't need unit tests for that. And that's something we absolutely want as a lazy programmer, right? Let me add a disclaimer here. The techniques that I'm going to show you can be used in all programming languages, especially the more general DDD patterns. But some make it easier than others, especially statically typed languages can get the most out of it, as these techniques can help you to catch more bugs at compile time. Still, even when we're using dynamically typed languages, some of these tricks can help improving your code quality. A powerful type system allows you to model your domain even more precisely in the world of types, so more bugs that can be caught automatically. 2 features that are very nice are sum types or tagged unions and pattern matching. For simplicity, imagine that sometimes some types are enums just way better, while pattern matching is the more powerful version of a switch case statement. Here's a small list of languages I tried to activate my laser pointer here. So here's a small list of languages which provide a powerful type system. I will use some of them because they make it easy for me to express powerful concepts in a concise way, so they fit on the slides better. But fear not, even if you have never seen that language, I will explain everything that you need to know for the example. And some of these languages had some types and pattern matching for decades now, like Haskell, and they are tightly integrated into everyday programming in those communities. The most popular languages in this list are probably TypeScript, C#, and Java. TypeScript has some types, but no pattern matching. C# has pattern matching, but no some types. And Java has both of them since version 17, but these features are probably still unknown to most people. And maybe talks like this help in making those features more popular. So I assume that all of you know what null is and the infamous null pointer exception that comes with it. Tony Hoare, who brought us this gift, called it his billion-dollar mistake. But what's exactly the problem with it? Null is a value that implicitly is part of every type. It can always be returned. And that makes it hard to provide reasonable advice that works in all situations. Some languages decided to avoid null completely and modeled the absence of values explicitly. Java and others have since adopted this idea. And now it's finally time to see the first code example, and it's in Java. So in this example, we work with a map structure, a key value store. Map provides a method called get, and you give it a key and it returns a value, but only if the value exists in the map. Else it will return null. So we want to avoid that. So the first function here builds a safe wrapper around it. This lookup function calls the get function, but returns an optional. An optional is a class that represents potential failure. It can either be present or empty. This means that a compiler can force you to provide checks for empty and therefore protect you against null pointer exceptions. In Java, there are still many places where null is leaking, but other languages that really enforce this null safety have a big benefit. If a value isn't wrapped in an optional, then the value is definitely there. So you don't need defensive programming where you check for null just to be sure. This simplifies your code a lot and makes it easier to follow the instructions. Get contact description or default is a function that now uses this lookup function. It receives a name and a phone book, which is just a map with strings for its keys and values. And first we call lookup and get back an optional of string. We can't return this value straight away because our function has to return a string and not an optional. So we could try to unwrap this optional, similar to how we provide an if check and check if the value is null. But optional allows us to use a more expressive interface. You can use the map function on optionals, like you can use them on lists, for example. And if the value is there, it will apply the provided lambda function and will do just nothing if the value is empty. This way, you can avoid the boilerplate of unwrapping a value. With or else, you can also provide a default case. In this case, if the name could not be found. And because string is not the same as optional of string, the compiler will force us to handle this case. Did you know that using the same basic data types for everything is an anti-pattern? It's called primitive obsession. So the problem with basic data types is that they do not enforce any constraints on the contained data. So if you generate UUIDs, but store them in strings, then someone could just manipulate them in a way that makes them invalid UUIDs. Storing them in a UUID type helps because the class can then protect the invariance of the data. But Using UIDs for everything still has a problem. You can mix different IDs up. In this example, I'm creating a simple wrapper around the GUID type that is built in C#. It's a record and immutable, so after its creation, the value cannot change anymore. It's a value object in DDD speak. The two methods are for easy conversation to its base type. Below that record, you can see the function store payment for user, which expects a payment ID and an user ID. If we then want to call that function, but mix up the IDs, we get a compiler error because the types do not match. With only a few extra lines of code, you can avoid a common source of errors. To get a better grasp of modeling concepts and ideas explicitly, let's try to model a contact type. We will begin with a simple model with only primitive types and steadily improve the design with rich types that encode business rules. This time, I will use F# for that. It has a powerful type system and has the huge benefit of running on .NET, so you can integrate it into existing projects and access the huge .NET ecosystem. Also, I will use some types which are currently not supported in C# directly. Let's dive in. Here's a type called contact. It contains a first name, an initial, a last name, and an email address, all strings. There's also this Boolean flag called isEmailVerified with a comment that this flag is set to true if the verification mail was confirmed. But what happens when the email address changes? Does it stay verified? We have to figure this out later. Looks like a typical contact type to me, but we can do better. There are now 3 types. Related data is now grouped into their own types. There's a type called personal name, containing name-related data, and there is this type called email contact info, containing the email address and the Boolean flag. Contact then wraps those 2 types. This can still be improved. Not any arbitrary string is a name or an email address. So let's fix that. The email type now lives in its own file. This gives us the power to only export certain functions from that module, similar to public and private functions in Java or C#. We use this to implement the so-called smart constructor pattern. Line 1 shows that the email address is still a string, but its constructor is private. Only functions in this file can access it. The rest can only use the type. We create 2 helper functions. We create 2 helper functions. A create function, which will act as our new public constructor, and a value function to extract the contained string from that type. F# is a statically typed language, but can fully infer all types, so we don't have to write them all down explicitly. The value function just unwraps the container type, but create is a little bit more elaborated. It accepts a string as an input and then uses a regular expression to check if the string contains an @ symbol. Not the best check, but we will later find a better solution. The function returns an option of email address. So it's similar to optional in Java. If the check succeeds, we return some with the email address. And if it fails, we return none. The caller then has to check if the address, if the creation of the email address was successful or not. As this function is the only way to create something of type email address, everyone is forced to go through this validation process. If we now look at the rest of our types, some other things have changed too. Instead of just using a string, our email contact info now uses the email address type. The names have changed too. They also use smart constructors, but in this case, they limit the maximum amount of characters allowed. So initial is also now marked with option to clarify that this value may not exist. And first name and last name are strings that only allow a character amount of up to 50 characters, and an initial can only be 1 character here. We still have this Boolean flag though, which doesn't really tell us much about our business process. Time to solve this problem too. The email module was rewritten again, and the type email contact info is now part of this file, and it is a sum type now. So it has 2 constructors. It's either unverified, which accepts an email address as an input, or it is verified, which accepts a verified email address as an input. Email contact info can then be either unverified or verified. So it's similar to an enum, but you can attach additional data to it, like what we are doing here. The constructor for email address is public, but verified email address is private and uses the smart constructor pattern. We have a value function, so that hasn't changed, but we got 2 new other functions: store verification code and verify. Store verification code expects an email contact info and the verification code as arguments and perform pattern matching on the contact. So with pattern matching, we can not only match on certain values, like what we can do with a switch case statement, but in this case, we're using it to match on the constructor that was used to generate this value. If the contact is already verified, we just return void or unit, how it's called in F#. If the contact is unverified, we unwrap the email address and store the address and the code in the database. The code can then be sent as an activation link to the user. Verify then later expects email contact info and a verification code. In case that the contact is already verified, we just return the value back wrapped in sum, because now we have a process that could fail. So we, in addition, only return an optional here. And else, if the value is unverified, if the contact is unverified, we unwrap the email address and check if the provided verification code matches with the one stored for this email address in the database. If they match, we return a verified email address with the provided mail address and return none if they don't match. So instead of using the Boolean flag, we now have static guarantees that can be checked by a compiler that all verified email addresses went through this verification process. Nothing really has changed for our contact type here, as it was already using the email contact type info type, but send password reset email and change email are example functions that demonstrate how you can now use these types to your advantage. So send password reset mail expects a verified email address as an argument. There is no way to send a password reset email to an address that has not been verified before. Similarly, change email is the function that is used when a user wants to change the email address. It accepts a string, and at this stage, the only available constructor is the unverified constructor, as the verified constructor can only be used in the verification flow. So no more excuses like, oh, I forgot to reset the flag when the data has changed. This was a brief overview on how you can use types to describe your business domain. But that was not all that types can give us. So let's hear more about them. Many vulnerabilities exist because it's so easy to make those mistakes. Let me present some ideas how you can use types so that your compiler prevents you from implementing some of the most common vulnerabilities. If you're not familiar with the OWASP Top 10, it's a list of the 10 most common security vulnerabilities classes found in web applications. They get updated every few years, and the 2021 version is the current one. I picked 3 of them because types can help us to prevent them. Broken access control is rather self-explanatory. Attackers can access data they should not have access to. Injection attacks refer to attacks like SQL or OS injections, but also cross-site scripting. An attacker provides input that gets interpreted as code, giving the attacker control over your server. Insecure design is rather unspecific and can mean many things. As we try to design our system in a way that secure becomes the default state, we avoid this vulnerability class too. The OWASP publishes other top 10 lists too, for example, for API backends, and they share some similarities with the previous one. Number 1 and 5 are broken access control. Number 3 is new. This occurs when you expose too much data to external clients or accept too much from them. So let's start with broken access control and how we can fix them. And this time we will see some Haskell code, but fear not, I wrote it as imperative as possible. So a company wrote out a new version of their web service, and shortly after, an attacker did bad things. It's our job now to fix this problem in a way that this cannot happen anymore. Here we have parts of a web controller. We have routes for get, put, and delete. Looks like a simple CRUD application to me. Fetch the current user, extract the article ID from the URL path, check if the user can access or modify this particular article, return 401 not authorized when they cannot, and perform the action when they are allowed. So, when this code was written, someone forgot to include the not here. This, of course, this could be just some simple copy-paste error, and I see errors like this all the time when I'm doing code reviews. And with the not missing here, this of course flips that Boolean check. So now legit users couldn't delete articles, but everyone else could. And an attacker swooped in and deleted everything. And that's why we have backups. We want to solve this problem once and for all, and types will save us. This is our new authorization module. In the top left, you can see the functions that were originally called and that return Booleans. But Booleans don't prove anything. Or Boolean checks don't prove anything. So once you leave the if-else branch, it's like no check happened at all, and you can call everything in your application again. We don't want that. We want static proof that is checkable by a compiler that an authorization check has happened. And we can use types for this proof. At the top right, you can see 3 new types. Access article and modify article both store the ID of an article. They can be seen as some kind of access level. Access token is a generic wrapper. It can take any type, which is just called A here. So, for example, an access token access article or access token modify article. And we have this function called token data, which just extracts the contained value, like the value function back in our F# example. Now, we have 2 functions, get access article token and get modify article token, which perform the authorization check using the old Boolean-based checks that were used before. The maybe here, they maybe return a valid access token or nothing. And maybe it's just Haskell's version of optional, and maybe can either be just or nothing. Like it could be some or none back in C F#. But what's so special about this? So when we look at the module definition here, we can see the export list of this function. So which functions are available outside of this module and which functions are private. For access article and modify article, this ... thing here means that we export constructors. So other modules can create values of this type and can unwrap them without a problem. That's why we don't have to provide a value extraction function or similar for them. But the constructor for the access token is not exposed. So the only way to get an access token is by calling the get access article token or get modify article token functions. And note that the Boolean functions are also not exposed. But that's only half of the solution, because the rest of our application does not expect any access tokens yet. So let's change that too. It's up to you at which layer you want to require the access token. In this example, the service layer, called by the controllers, expects the tokens. So before our refactoring, these three functions accepted the article ID directly and did their job. Now they expect the access tokens instead. And note how they only require the permission level that is necessary for the job. Like get article only needs to have access or read access to the article, but put and delete, they need the permission level to also modify them. So we got a nice implementation of the principle of least authority going on here. And the implementation is very trivial. They get the token as an argument, they extract the token data, and then extract the article ID from the permission, and then they just pass it to the underlying database function that was used before. So it's literally just one more line for unwrapping the token. So we haven't really increased the complexity of our code with this change. The last place we have to change is our controller. So instead of calling our Boolean-based functions and using if-else, we now call our new authorization functions and pattern match on the maybe. If we get nothing, we return the 401 not authorized. If we get a just with the token, we give the token to the service layer where they do their job. And that's all there is. At the end, we only had to add a few lines of code for wrapping and unwrapping the access tokens, because you have to write some kind of authorization logic anyway. So we just added types to convert these checks into static proofs, and therefore our compiler forces us to perform authorization checks. And if you think about it, we use types as access tokens, similar to how others are using signed tokens for authorization. But instead of cryptography, we are protected by the runtime of our language. And by making the constructor private, making it the only place where values of this type can be created, it's like using a private key to sign some piece of data. And other functions only accept data that has the right signature. And while we are at it, let's stay for Haskell for the next example. So let's tackle injection attacks now. We have another Haskell application here that uses SQLite as its database engine. It gets a connection to the database, asks the user for a product name, searches for it, and prints the found products. We use a simple database library here, not a fully fledged ORM, and we have to write a SQL by hand. This sounds like something that could be susceptible to a SQL injection. If you make the mistake of concatenating the SQL query with the user input, you are owned. The solution to this are prepared statements, of course, but that's something you have to know and actively think about. So what's the magic here? It's simple. A SQL query is not a string. It has the type query. And it's not even a very sophisticated data type. It's literally just a wrapper around normal strings. But all relevant functions in that library expect the query instead of a string, like this query function here. No, not this one, like the query function here. So this distinction between a query and a string avoids the number one reason for SQL injections: accidental string concatenation of user input with queries. On line number 10, you can see that I explicitly convert the SQL code by calling the query constructor from the SQL module. Performing a concatenation of the query and the string from the user would result in a compilation error because the types don't match. And in this case, the wrapper even gets eliminated at compile time. So there's absolutely zero overhead of using this technique. Rust isn't the only language with zero-cost abstractions. It happens that we have to deal with data that can be considered as valuable or secret, and using them inside our program is usually not a problem. But we have to be careful not to leak them to the outside. In this Java example, our user class contains the password hash of the user. That's something we would like to keep to ourselves. And do you see this idea of user type here? It's a different way to tackle the mixed ID problem. Instead of having an explicit type for every single ID that you could have, ID here is just a generic wrapper class, accepting any class. And it doesn't do anything with the types, so it can accept any class here. It's just here to differentiate between different kinds of IDs on the type level. And this pattern is known as phantom types. Now, to solve our data leak problem, we will use data transfer objects, DTOs. Here I called it user view model to give it a more explaining name. A DTO is a separate data type specifically made to be used for data exchange and crossing boundaries. That's why we have to fall back to primitive types here, because other applications would not understand our custom data types. When we create a DTO, we are in the mindset of returning only the necessities to the caller. In this case, the caller does not need to know the internal ID of the user. We also know that the first and last name are always displayed together in our frontend. So we provide a single computed property here called full name. We return the date of birth, but as the datetime type and not our custom birth date type. And of course, the password hash stays with us. The user view model is also responsible for providing the methods to convert from and to the domain model. So the outside world is no concern of our domain model. So putting some serialization logic here wouldn't be the best fit. And this makes it easy to change, for example, the serialization library without having to touch your core types. Get users could be a function in our controllers. It calls the user service to get all users. And at this stage, they still have our domain user type. And then we map over these users, convert them to the view model class, and return those back to the caller. And one benefit of using custom domain types is you have to provide conversion functions anyway. So as no external code will work with your types out of the box. So you might as well use this chance to prevent some security issues. And applying the reverse then solves the other problem described within broken object property level authorization. It's when an attacker provides more data fields that you expect, but your application is still processing them, like changing the role of a user to admin in a function where only the name should change. And to solve this, you explicitly create another DTO for input data with only the fields that clients are supposed to modify and later convert them to domain types. Elm is a functional programming language, architecture, and framework for creating single-page applications for the web. And it transpiles to JavaScript and has the most friendly and useful compiler errors you have ever seen. And while you might not have heard about Elm, there's this other small SPA framework written in JavaScript called React that was built on a lot of ideas that originally came from Elm. So you write web frontends with Elm, so preventing cross-site scripting attacks is a huge concern. And the solution to this problem is similar to the one for the other injection attack. A web page is not an arbitrary string. It's HTML, which has certain properties. You can only return web pages if they have the type HTML. There are a few functions that accept strings and convert them to HTML. Text here is one of them. All these functions perform output encoding and escaping, so JavaScript code does not get interpreted as code when displayed in HTML. Again, the compiler is forcing you here to pass your potentially dangerous user input through a conversion function that takes the danger out of it. You cannot forget to do this. The compiler is your friend. Even JavaScript has more strict types now, and they are called trusted types. And some single-page application frameworks like Angular are already using them to further improve security. Now, some of you may ask, does this work with all applications? And the answer in general is, it depends. But there's one particular architecture for business applications that work especially well with this domain-driven approach. And it has many names: hexagonal architecture, onion architecture, clean architecture, also ports and adapters. And the functional approach to this is called pure core imperative shell. They all describe roughly the same idea. Your business logic should be in the core of your application. The core does not depend on any external systems. All layers point inwards dependency-wise. The core provides interfaces which the outer layers then implement. So your rich domain types live in these two inner layers, validated, filled with business logic and protected from the outside impure world. In the other layers, you provide your DTOs that bridge the gap between your application and the real world. They filter out the nasty stuff so your business domain can work with good and well-structured data. This keeps you on the happy path and makes your most valuable code easier to maintain, extend, and understand. At last, here are some book recommendations. If you want to learn more about functional programming and domain modeling, I can highly recommend this book by Scott Vlashin. I've read it multiple times, and it's a great resource for ideas that will make your programming life easier. The examples are all in F#, but the lessons you will learn are valuable in all languages. And Learning Domain-Driven Design by Vlad Kononov is a modern primer on the principles of domain-driven design with lots of practical patterns and concepts, and also not as dry as some other DDD books out there. So the key takeaways: make illegal state unrepresentable. Less tests to write, less bugs to experience. Encode business rules in your types. Guide other programmers by designing your types and functions in a way that makes it obvious how to use them, connect them, and what to expect. Parse, don't validate. There's actually a nice blog post with that same phrase. If you perform any kind of validation or check, embed that knowledge by wrapping it in a type. Boolean checks are ephemeral. Once you leave the if-else, there's no proof that you have ever performed the validation. Use the compiler to your advantage. Let it prevent you from doing stupid mistakes. Using rich domain types basically lets the compiler write free tests for you. It makes sure that you cannot call functions with invalid data. Tests for free. Don't miss this offer. And last but not least, eliminate security vulnerabilities by design. You get great security when it's the default, and you have to do extra stuff to shoot yourself in the foot. And with this, we are done. Thank you for listening, and I'm happy to answer all your questions now.
Hello again, Michael. Yeah, thank you also for this superb talk. And yeah, even though you shed much light on this topic, we still got some questions. So if you're ready, we will tackle them right away. Yeah, stay hydrated. That's important. Yeah. So, first question. In which programming languages have you found the most effective type systems for embedding business rules and security properties?
So I presented this list before with a few languages that where I think they are particularly suited. In my experience, the languages that come from the functional programming world are a bit better suited for this. But like I said, it basically is possible in all languages, but it might not be as elegant. For example, even though Java supports many of these cool features now, in Java it's common to have one class in one file. And now, if you have maybe some more complex types with like a subtype that could be in 5 different states, splitting this up in 5 files might make it again more confusing, because now you have to switch around files and it's not easily presented in one thing. So it depends not really on the language, but also how is the community working? Is this an established practice? Goes it against everything best practice in with this language? So usually the languages itself are not a problem, but everything around it. And you don't want to be the outsider who does everything else, and then no one wants to work with you anymore. So it's more like this is usually the problem and not the technical base.
I see. Thanks for this explanation. So, and we tackle the next question. What are some limitations of strict type systems and how do you tackle them?
So I would love to say there are no limitations. And basically all common languages always have some escape hatch to do things in a very direct, maybe unsafe and nasty way, but it's always possible. It's always some you always need to think about, okay, we can make this very complicated and do everything on the type level, which is certainly possible with some languages. But at some point, yeah, you get all these nice benefits, and stuff can be done completely by the compiler and maybe even completely auto-generate functions and all that stuff. And that's certainly cool. But if no one in the end is able to understand what the program is doing, then you might have switched one nice thing for a bad thing. So it's always a compromise. The things that I try to present to you, these are things where I think they are quite easy to implement in your own programs. They don't have a lot of overhead. They prevent mistakes and are certainly very useful and are compatible with a lot of languages. There are many more things that you can do to further dive deep into this idea. But at some point, yeah, it makes things more complicated, harder to understand. So it's always this challenge to find the right mix.
Right, thank you. We got another question for you. Is front-end validation relevant when we do back-end validation on our app?
That's a good question, because this is oftentimes a security vulnerability that we find, that validation happens only on the front end, but not on the back end. And one of the core messages is never trust the client. So from a security perspective, if you do everything on the back end, then you are good to go. You add validation on the front end to improve the user experience. So before they're even able to send some invalid data, the browser can directly say, hey, you input like a string, but we are actually expecting some kind of number here or a date in a specific format. And all these front-end validations helps here with the user validation, so you don't have to round trip all the times with some weird error messages. But from a security perspective, practically, front-end validation is not important, and everything happens on the backend side. Yeah.
Makes sense. Thank you. Next question. Do you think strong type systems could be a barrier for beginners?
So it depends on how well you structure your program. And in my opinion, if you do it right, then it could even help beginners. So if we have this workflow with the whole email verification thing, there's like, if you have none of these checks and everything is basically using some public constructors and everyone can just change around the values of any contact type and there are no protections anyway, then it's quite hard for a beginner to really understand how to use it, and maybe they use it wrong because there are so many things that that can be used wrong here. But if you really try to limit all this and basically only provide like, this is the one way how you can use the contact type, and this is the only way how you can change the email address, and this is the only way how you can verify the email address, then it's like quite easy for a beginner to just follow the types and get the whole business process at the same time. So I would say if you're doing it right, it could even help beginners here.
Yeah. With a clear structure. Thank you for the answer as well, Michael. So continue talking about strict type. How can strict type systems improve the quality of code for beginners?
Yeah, so the answer is similar to the previous one. So strict types just prevent you from doing a lot of invalid things. So you are quite limited in the ways you are able to use this data type. And if the type is designed in a correct way, then you basically can only do the right things with it. So, so it doesn't matter how a beginner is then using these types, all these ways are correct. And also beginners might not be in the mood, not in the mood, but may have not the experience to do stuff like test-driven design and that they should write tests first and all that stuff. And if you have very strict types where your compiler is basically doing all the testing for you, then beginners who are not that into writing tests still benefit from all the strict types here. So I think that's a good way to start into a program.
Awesome. Thank you, Michael. Good. And we got another beginner question. I'm new to programming. Should I start learning with a language that has strict type checks? Which one would you recommend? Currently, I'm using Java and Python.
That's a very good question. The opinions differ here. There's a wide spectrum.
Religious war.
Yeah, it's incredible. I'm a bit more on the strict side. So I think, my opinion, if you start with a language that basically allows you to do anything like JavaScript, or Python is a bit more strict, but JavaScript or PHP, which have not really much checking implemented into the language, of course they can quickly start with anything and they might produce quick results, but the thing that they produce might be very ugly. And after a few months or even years, it depends on when does this beginner really start to having a good mentor, for example, or when do they start to think about quality and maintainability. It's maybe hard to get rid of all these old habits once they are ingrained in you. And in my opinion, if you start with a more stricter language, and with these two languages, I would say Java is more strict than Python here, alone by the fact that Java is statically typed, so you have the compiler and you can already detect stuff during the compilation and not while you're running it. If you are in this world where you basically are forced to write more concrete code, then you learn the good stuff and good architecture more from the beginning, and then it's easier to improve on that knowledge instead of, okay, you have a lot of old bad habits and you need to get rid of them. So my opinion would be, with these languages, for example, I would go with Java and get a lot of benefits that Python maybe don't give me here.
Get used to the difficult stuff from the beginning. It will pay off in time.
It will pay off, yes. And also maybe if you look at some very large projects like Twitter or many others, but like many projects start with some easy language like Python or Ruby, and at the beginning everything is cool and they're scaling and it's great, but at some point all this complexity is very hard to manage if your programming language doesn't help you in any way with refactoring or making sure that all the code paths are correct, because everything is dynamic, and if you don't have 100% test coverage, then you never know if stuff is still working. So at some point, most people switch to static languages anyway. So why not start right in the beginning with it and get used to it?
To prevent the spaghetti code when the project is growing. Yeah, makes totally sense. Thank you, Michael. Let's tackle the next question. How do you approach integrating type-based security into legacy code bases with minimal disruption?
Yeah, legacy applications are always a very interesting problem here. I guess there are maybe few approaches. One of the easier ones would really be to start thinking about these very simple wrapper types, basically, where you just have to wrap the value into this new type and later unwrap it, because they contain most of the original business logic, and you just now add these static proofs with instead of having booleans with if else checks, you can now check on, is this value the correct type or not? And like they're very simple to add and also easy to add into legacy applications. Larger refactoring like this email contact info, these things might be harder because now you really have to understand all the old legacy application code. Maybe the code, well, not maybe, it certainly will be not in a single nice place, but probably distributed across the whole application, and there's a relevant piece there, and then there's another relevant piece there. So it's very hard to really consolidate all that info because you need to completely understand the legacy application and put it into a new place where now everything is in order. But I guess really starting simple and building up slowly on that is a good way to approach the whole situation.
Mm-hmm. Thank you, Michael. We got another question for you from the audience. How do type systems help in preventing injection attacks like SQL injections or cross-site scripting?
Yeah, so I talked about it. The main problem with SQL injection is that the SQL query and user input, the both strings are concatenated with each other. So the SQL server doesn't know that the user input is actually user data and not also part of the SQL, and that's where we have the problems. And with the cross-site scripting, the browser doesn't know that part of the HTML was originally user data and that it shouldn't treat this user data as code. And the type systems can help us here by just differentiating between different things. So the SQL query is not just a string. A SQL query is of type query, for example. And with the HTML and the browser and the cross-site scripting, the HTML part is like of type HTML, and user data is something different. And you have special functions that then combine all these things and do the right things. And because these types do not match, you have to explicitly convert them into the right data types. So it's not possible to do the wrong thing accidentally. You are forced by the types to use the right types, and the functions do the rest for you, because these functions are the only way to get the correct type. And these functions already have the security checks, output encoding, whatever built in.
Thanks, Michael. And one more question. Do strong type systems only help with security, or do they have other benefits too?
They have a lot of nice benefits. So security is actually one of the lesser known things here. That's something that I try to promote now. If you have a really good type system and also you are using a statically typed language, then like if you write a program and then something is wrong, you will notice because the compiler says, hey, you are trying to combine a string with an int here, or you updated a dependency, but the dependency, the function name has changed, or the function now expects 2 instead of 3 parameters, or the thread parameter has a different type now. These are all things that are not automatically checked with a dynamic language. They only are checked when the program is running. So instead of you seeing the problem, it's basically your customer, which then complains to you, why is the program broken? And besides that, if you have strong types and really use these types, and not only the primitive types, but really are trying to have a rich domain, then you get other benefits, like it's easier to understand. You now have functions and types that also maybe a non-programmer could read. So no one knows what an abstract factory bean whatever is, but if you give it a very explicit name that makes sense in the context of your business, then even other people can read it. And so your code somehow also becomes your documentation, but they never can be outdated because it's the same thing. So that's also very nice.
That's a nice trick. All right. Michael, thank you so much for your talk today. It was a pleasure having you again. Thanks also for the Q&A and answering all these questions from the audience. And yeah, I hope you have a nice day, and hopefully we see each other again on another live day.
Hopefully, yeah. So have a nice day. Have a nice conference. Bye.
Thank you, Michael. Bye. All right. And now we jump to the final speaker of today's Security Day. She is developer relations engineer at Neo4j. She engages with community not only by speaking, but she is also blogging. And her passion lies with finding ways to organize chaos and deliver software effectively. Very welcome, Jennifer.
Hi, thank you.
Hi, Jennifer. Thank you so much for tuning in. May I ask how late or early it is at yours?
It's 7 a.m. here.
7 a.m. Then thank you so much for getting up this early for us. I hope you had your morning coffee.
Yes.
And perfect. It's here. So, okay. So you are well equipped, I see. Perfect. Yep. So Jennifer, before we jump in your talk, would you mind sharing a bit with us what we're going to learn from you today?
Sure. So we're just going to take a step back here and look at cyber data as a whole, but organizing it in different ways. So we're going to look at it in a graph database, and this is going to show us how we can change our perspective from thinking more in a list format or, rows and columns to something that's much more connected and much more network oriented. And we're going to show how this really can expand our horizons as well as help defend against potential attackers.
Perfect. Expanding the horizon is always a thing we should aim for. So yeah, Jennifer, I don't want to steal any more of your talking time. The stage is all yours.
Thank you. All right. So my name is Jennifer Reif, and I have my contact information there in the lower left. It'll also be on the next slide and on the final slide too. So if you think of a question past the point of this event, weeks, months down the road, by all means, reach out on whatever channel is most comfortable. I'm happy to talk tech, Neo4j, data, graphs at length at any time. So just a bit of background on me. There was a little bit of a fantastic intro on this already, so I won't spend too much time here. I like to learn technology, and then I like to share that technology in a variety of different ways. So whether that's through speaking at either in-person or virtual events, such as this one, or coming up with videos, or podcasting, or lots of other things. I also really enjoy tech blogging. So I have several different blog posts out across a variety of channels, but many of them are hosted on my own site that's in the in the contact as well. So feel free to check that out if you're interested. I have hobbies outside of work, but most of them boil down to the fact that I'm just kind of a geek at heart, and I kind of enjoy that, if you couldn't tell from the picture there. Okay, let's dive right in. Let's talk cybersecurity. As I'm sure most of you are probably aware, or you wouldn't be on this event, right? Cybersecurity is really diverse. There's lots of opportunities, as well as kind of categories or topic matters within cybersecurity. As with most things, but especially in kind of tech in general, right? This graphic was done for a blog post that's linked down there with the LinkedIn URL there. So if you want to find the original source, and there's a whole blog post and everything talking about putting this together. But we can kind of see we have kind of the central, cybersecurity domains kind of hub, if you will. And then we have kind of some categories. So we have security operations, user education, threat intelligence, governance, risk assessment, framework and standard, security architecture, career development, and then also physical security involved in that too. And then within each one of those break down into further kind of subcategories or smaller topic areas, right? So very diverse, very complex. If you looked at any one particular topic, trying to source back and figure out what all is related to it or how it falls under what umbrella within cybersecurity and so on would be perhaps complicated. Let's take a different kind of view or path of cybersecurity. This is for an attack chain for the WinRAR RCE, which I believe was 2018, although the blog post article is from 2019 there at the bottom. So that's the source article there from Microsoft. And we can see that this entire exploit started from a spear phishing email. But we can see it kind of takes a multiple path or hop trajectory here. You have a document with an attachment with a bad URL. It downloads something. You have a macro that gets kicked off there. It does some back-end things with PowerShell and an image, and it creates a backdoor, collects some system info, has an exploit that drops a payload, and so on. So you kind of have this path that it works through. It doesn't just immediately drop into the system and take over, right? It kind of has this multiple sneaking steps that go along with it. Who are we up against as defenders? Hopefully, most of us, and not hackers. Who are these hackers? Who are we trying to defend things against? Well, some of them are everyday people, right? They're everyday users, maybe some more technical than others. Some of them might be kind of enemy organizations or countries or who knows, groups of any kind. And so you have a variety of different spectrums here, from just kind of a typical user to kind of enemy organizations or larger groups, right? So it's very complex and intricate. How do you surface those bad actors from any other kind of regular user, right? And so that can be hard to surface and find. We have lots of cybersecurity tasks. So our goals as cybersecurity individuals are to identify and prevent attacks. So things like DOS and ransomware. We want to avoid disclosing private or sensitive data. That happens a lot, right? We want to avoid any more of that if we can. We want to prevent unauthorized changes to applications or privileges that shouldn't be there. And we also want to prevent unauthorized account access, someone taking over somebody's account and acting like a good citizen, but then doing other things in the background that we don't want occurring, right? How do we fight all of these different things? It's a lot of ground to cover. Typically, you'll see separate hardware solutions. So you'll have things like packet sniffers or looking for malicious URLs, or you'll have even just the physical security aspect. You'll have things for scanning badges and checking identities and so on. So you have to tackle a lot of different aspects. Typically, what you'll see is you'll protect and harden up the internal accounts and avoid those exploits and try to cut those off as early as you can, right? But what about the external accounts? What about the people who you want to be in the system, the customers and the partners, but that aren't internal to your network or that aren't internal to your company or system? How do you safely allow external access, but then avoid any security breaches from that point. And then looking at exploitation pathways. What do you do when you do have an exposed account? How do you shut that down? How do you prevent any further damage, and so on? And there's lots of different action paths here. You kind of have two different paths you could take. Hopefully, some of both, right? You have a reactive path, which means that you're going to have a security incident. What do you do when that surfaces, and how do you shut that down and prevent damage and clean up the damage that's already there? And then the proactive approach. How do we prevent these things from even getting in the first place? So, recap of the problem really quickly. You have lots of complex, very intricate data. Attackers are going to look for gaps across a lot of different vectors and a lot of different areas, right? You have lots of cybersecurity tasks to mention. There's a lot on your plate, a lot of things you have to try to juggle. You have to compile multiple data sources, lots of different tools, and so on. And you need to strategize from multiple perspectives too. Again, reactive, proactive. Where do we cut things off? If we have this or if we have that. Lots of scenarios that you need to cover and figure out the best way to approach each one. What do all of these scenarios have in common? The security images we looked at of cybersecurity and the exploit and some of these other things, they're graphs. So connected data is going to give you a graph. And just from this image here, we can kind of see that Jennifer node in the middle is kind of based on me. It was a graphic I created a while ago. But we can see that the blue nodes are going to be your people. And we can start to understand Jennifer's circle or her network, and maybe her habits and the things she does on a day-to-day basis by just looking at the things that she's connected to. So for instance, Jennifer there in the middle, I have people that I'm friends with and they have other connections connected to them. And Jennifer also has a company she works for. She has topic areas or parts of technology she likes, like Java, graphs, so on. And we can start to understand, okay, she works for Neo4j. So liking graphs maybe, or at least working with graphs, it makes sense. She also likes Java. So maybe that's part of her day-to-day work, or maybe it's just a hobby, category of technology she enjoys. She's connected to other people. They have additional likes and companies they work for. So Jennifer then by indirect relationship has connections to these other things as well. This is a tweet that I think has probably been quoted here and there. I know for sure Neo4j has used it some here and there, but maybe many of you have seen it as well. And this is back from 2018, so it's getting quite a bit of mileage. Defenders think in lists, attackers think in graphs. As long as this is true, attackers win. And we're going to kind of look at why this is true and how to combat this. So this is from John Lambert. He was Microsoft Threat Intelligence officer there. So let's just unpack this a little bit. Defenders think in lists. We see things, many things, not just cybersecurity, but even our task lists and things we want to accomplish and strategizing for the future and so on. We look at this very much in a list format. So for cybersecurity, we see the list of access a user has. We might see a list of groups either that are available or that a specific user or team has access to. Lists of permissions that are accessible or available. Lists of applications that the company owns or that people have access to or that we manage and maintain. And then lists of steps to perform. So I've seen some things where you have like a cybersecurity checklist, do all these steps, or maybe you have a breach and you're going to, do this first and then this and this and this and then this. So very list oriented. How are attackers different? Well, they think in graphs. And a good example of this is just looking at an entry point. They'll look for any small gap in the system, right? And then they hop from there and see what else connected to it. What can I get access to next? Okay, this little piece doesn't have access, but I'm in. Okay, now what can I hop to that gives me a little bit more access or at least in the right direction where I want? And then, okay, I got there. Now, how do I jump to the next thing to get me more? And so if they get access to an admin user, that admin user has a connection to a workstation, right? They'll have a login or a session there. And then that workstation might be connected to the domain controller. And if they can get access to any one of those things, then they have keys to the kingdom, right? Or even, okay, they don't get access to an admin user. Let's say they just get a regular user, but that user has groups that then have access to machines and can do things on those machines. And then they might be able to hop from there and get an admin user's access. And then they might be able to do the same things that we just looked at, right? So it's where can I access, even though, this little entry point that I found might not have hardly any permissions. If it has just one little gap, they can use that to jump to the next thing. So for instance, we looked at this exploit. This was the same exploit, same slide we looked at just a couple of minutes ago. It started as a spear phishing email. And then you looked at, okay, what can I do from this point? They didn't, again, just drop everything in and say, take over, here we are. They used a spear phishing email that had a URL, that had a little download with it, had a little macro in the background. Most people wouldn't notice. It flies under the radar, right? And these little things aren't a big deal, but incrementally, as you add them together, that's what becomes a major exploit. Okay, so for a path, connections are going to present attack paths. And there's not really a way we can have a completely disconnected network, right? Or a disconnected system. That would make work and business really, really difficult. So we naturally kind of create these networks without even realizing it. But then how do we help prevent attacks using that network? So for instance, this is a blog post, the same blog post that tweet was from, by the way. Defenders think in lists, attackers think in graphs. So that GitHub link is there at the bottom if you want to see the source document, and it has the full blog post and everything that goes along with it. So this is a graphic from that. If someone gets access to that terminal server on the lower left of the slide, they have multiple attack pathways they can use to get to that high value asset on the upper right. So, maybe one, let's say that M2821 machine kind of in the middle top is super secure and is locked down and has, really tough security. But they don't have to go through that machine, right? They could jump to a different user. They could hit that M115 machine. They could get up through that user one and then jump to the high value asset. So even if one particular aspect of the network or one particular person is super secure, there are other avenues to get there, right? So you have to make sure the entire thing is secure or that you're taking good precautions. Or when an exploit does happen, you know how to shut down all of those attack pathways so nothing on the system remains. So networks are connected graphs. Graphs will give you a holistic view of a network. It helps you surface hidden connections. You can combine a variety of different data sources and look at direct or indirect relationships. So the Bloodhound Handbook, which is actually the data set we're going to be looking at today, in a graph, the Bloodhound Handbook has this image there that's in the lower left of the slide. And the author said, this is how I would explain graph to a 2-year-old. Which I thought was pretty cool, and kind of a nice example to at least to start with. So we have these people in green along the bottom. We have things they might like. So for instance, food items in this case. So for instance, we could use this in a couple of different ways. First, we know that Bob and John both like pizza. Bob also likes cola. So maybe for John, we would say, hey, we want to introduce you to Bob. He also likes pizza. You have something in common, right? So we could use this as kind of here's a new connection. We could also use that as a potential recommendation system, right? So we know that Bob and John like pizza. Bob and Alice like cola. So maybe we want to recommend cola to John as well. Hey, friends that you're indirectly, in this case, connected to, like cola with their pizza. Maybe you would too. We could also just look at the network as it is, so the direct relationships. Okay, we know John likes pizza. Maybe our new pizza release, we would want to send a marketing campaign out to him because we know he likes pizza. Or maybe we want to get together all the pizza lovers in a group. And so, okay, we know from the graph, this is who we need to send the invite to because we know these people like pizza, so on. So it's going to provide a unified view, and there's some naturally visual analysis and tooling around graph structures that you don't get with a lot of other data structures. Graphs can help. They're going to approach data differently, but it can help you minimize impacts by quickly identifying risks, detecting anomalies, and protecting systems from a variety of different avenues. So let's look at how we build a graph. This is great and all, but how do we actually put this into practice, right? If you're familiar with the mathematical concepts of graph theory, the graph databases are built on the very similar or same things, right? So we have vertex and edge for our kind of more broad terms of node and relationship. So graphs are made up of nodes and relationships. Nodes represent objects or entities. You can label them, basically like categorize them or group them, and you can have properties that go along with that. So for instance, we have our just a kind of a typical product purchase structure here on the right that we see. We have an order. It has some properties or some properties in this case, or metadata, if you will, order ID and date. A product might have a product ID and a name that goes along with it as metadata. Employee has an ID, a start date, position, so on, many of other things. And so you can kind of add additional metadata. You can categorize these nodes. We have, a set of orders, sets of products, sets of employees, and so on, right? Grouping of lots of different nodes here. Relationships have to have a type and have to have a direction. You can also add properties to relationships, and nodes can have multiple relationships. So for instance, our kind of graph on the right here, we have an order contains a product, right? When you make a purchase, you usually have kind of sub or line items, if you will, of different products that you made on that order, or different products that you purchased on that order. But we also see an order has connections to an employee too. Maybe an employee sold a particular order, especially in kind of larger purchases, right? And so you'll have a date maybe associated with that, and maybe a tip, especially if you're in like a service industry, right? So employee is connected to order in that way. But an order might also have a contact. Think of in business perspectives, right? Hey, if something goes wrong or the product's not what I expect, I contact this particular employee that made the sale, and they'll help me with customer service and getting what I need. Or you might have something where an employee actually created an order. So for instance, maybe that employee picked up a coffee on the way out of the shop, or maybe they purchased swag from their IT organization, right? And so an employee might also then kind of be a customer in that respect. So they could have that new relationship between an employee and an order. Labels, I've mentioned, are kind of a group of nodes. It's kind of like a category. So for instance, we have all these people entities or nodes that we've labeled as person, but we could also have additional categories that further define them or categorize them into kind of smaller groupings, right? So we have all these people. Maybe some of them are employees, some of them are also customers, and then we might even have some overlap. Remember that employee who made a purchase for, some swag or coffee or whatever it is from their workplace. Now they become kind of multiple different things, right? Multiple different facets. So that person could also be a customer, could also be an employee, and so on. All right. So working with Neo4j just a little bit. So there's a variety of different ways to put data in, take data out, and so on. We'll talk about a couple just kind of high level, but I have more detail in my GitHub repository on this. So my kind of preferred way is to use Cypher and APOC. So Cypher is our query language that Neo4j uses. Other companies, other graph databases use it as well, but Neo4j was kind of the core starter on that one. And then our APOC library is a utility library that kind of goes along with that and expands the capabilities of Cypher with some other things. So that's one method to go about it. The next way I have listed here is the ETL tool. This is really great if you're coming from a relational database system and you want to just do an initial dump of the relational data. It doesn't do incremental updates. It's not super customizable, but again, just really good to say, okay, I have all this data. What does it even look like in a graph? Let's just dump it and see what goes here or how it goes. The last option here is actually what I've used to get this demo up and running is a dump file. Now you do have to be a little bit careful. It's not going to be backwards compatible. So whatever version the dump file is on of Neo4j, you can't load that data into an older version of the database. You have to make sure you're loading it into, the same or newer version of the database. So I'll have all this information in the GitHub repository for how to do this. The dump file was actually pretty easy. I hadn't done one in a while. I usually did Cypher and APOC, but I did do a dump file for this, and it was actually really easy to get started and up and running. Next, let's talk just a little bit about Cypher. So this is as being one of the options for import and export, and we're going to be using Cypher again in the demo here in just a minute. So if I wanted to create this pattern in the graph, Jennifer works for Neo4j. This is the Cypher statement I would use to do it. So I would use the create keyword, which is like an insert, if you're familiar with SQL. And then we need to create two nodes, right? A Jennifer node, a Neo4j node, and that works for a relationship. So our two nodes are going to be encompassed in parentheses. So we have kind of these parentheses. And if you bring these parentheses together, it forms the circle, which is the visualization that you see right above it. So it says Cypher is very powerful and expressive. It's very visual, and it tries to, as much as you can, mimic the visualization that it coincides with. So we have our two nodes in parentheses, and you kind of even see the works for relationship is kind of an arrow with the brackets around the relationship type there. Within each node, we have a label. So we're going to categorize these nodes either as person or as company, right? So it helps us group and look for these entities. Last but not least, we'll have metadata that goes along with this. So we have a person with it's like a key value pair, a name of Jennifer, a company with a name of Neo4j. And so we would use this Cypher. It'll create the pattern for us in the graph. Now, what do we do? Maybe when we want to retrieve that path back out of the graph, we want to search for it and find it. We would use the match keyword, which is kind of like select. And we know we have a node, the person, name of Jennifer. We know there's a works for relationship, but maybe we don't know who Jennifer works for. Maybe we want to find out all the details that the graph has on that other entity, that related entity, right? And so we could just put a variable placeholder in. In this case, I've just used home for that second node. And then we want to return everything the graph database has on whom. So all of the properties and details about it. And of course, we know that it's going to return Neo4j because we have that in our visualization right above it, as well as we just created that pattern in the graph itself on the last slide, right? So it's going to return all that information that it has on Neo4j. All right, so how to load a dump file. If you're using our database as a system service, which we have a free tier for, you can spin up an instance in the cloud, and it will be fully managed and hosted by Neo4j. And then you just go to this import database tab in that, and you'll just drag and drop the dump file. And the dump file is included in that GitHub repository if you want to create this afterward as well. So you'll just wait a few minutes for it to load, wait for everything to kind of come up, and then you can start looking around and querying the data. Now, with the APOC library, this will be in the GitHub repository shortly. I've started on it. There's a couple of bugs I'm trying to work through and fix, so that will be up shortly. But this will be an alternative that'll be included in the GitHub repository as well. So if you have CSVs or any kind of flat file, JSON, so on, you can use Cypher and APOC, which is kind of my preferred or favorite way to do imports usually. You can use, if you have CSV, you can do a Cypher load CSV command, or you can also use the apoc.load.json or CSV or whatever data format you're working with procedure, and that will help you load in whatever file you need to access and then create the data from that file. So typically, after you load that data in, you'll do a merge on those particular nodes and relationships that you have. You'll set properties on your nodes and relationships. And then there's lots of APOC functions and procedures for data manipulation and cleaning. This is one of the reasons why I love loading with APOC is you can clean up data, you can manipulate it, you can change the data model. There's lots of options out there. So if you're interested in something like this, or you're having issues getting data in, check out APOC. Okay, let's actually demo this and see this in action now. I'm going to switch over here to browser. And find my mouse, of course, too. So this is Neo4j Aura. This is our database as a service. I've got a few different instances. Notice I have a bunch of free instances spun up. So there's lots of options. There's also paid tiers and so on, but we have a nice kind of free tier that you can just play around with. All right, without further ado, let's jump into our tools here. So I have a cybersecurity data set loaded into our graph. And so now what I want to do is start running some queries and see how this graph data can help us. So let's just start out with looking for a set of users who have some access to systems, right? So either they're a member of maybe some groups, or maybe they can RDP into certain machines. And so let's just do any other type of node here. So I've just created, again, a variable placeholder there called other. And then we want to return everything. And since this could potentially be a lot, I'm just going to limit the data set to 50 so that it loads in the browser quickly here. So we have just a sampling of our data set here. We have kind of this core domain group in the middle, which looks like it's a set of domain users. So it's a general group, I guess. And then we have lots of users connected to that. And then they have additional groups that they have access to. But we may want to look, make sure that this particular kind of general group is very secure and kind of limits access in certain ways and so on, because it seems like lots of users are connected to that one. So this is probably a very central grouping that a lot of people have. Okay, this is just a rudimentary look though. This is just a general kind of analysis. Let's kind of look at the data that's here. What if we had a user that came to us and said, hey, I got an email, it looked a little suspicious, but I ended up clicking on the link and I'm not sure if, I've been compromised or not, but hey, could you look into this? So, okay, let's start looking at a particular user. And we know she has a display name of Henrietta Nuremberg. And let's look at the machines she has access to first. Can RDP. And we know we have computers here. Okay. So let's return everything. Oh, okay. Not too bad. We can handle this, right? So here's our Henrietta node. Falls under a particular domain. Here's her display name. Here's the username that's associated with her account. And we can see some other details kind of involved around that user. Now we have the 3 machines that she has access to. Okay, so we have run some graph data science algorithms on these entities, which we'll look at a little bit more in detail in just a minute. You can see the PageRank score is pretty low. It goes from a score of 0 to 1. And so this is pretty low. So not too much influence here. Doesn't look like she has really access to any, scary important machines, right? But let's take this one step further. Okay, we know she has access to computers, but what are the groups that she has access to? Let's dive in and look at member of, and then look at the groups that are connected. Okay, let's return that. Oh, and actually, this is just a single hop. So you can see this is all the direct groups that she has, but we know that some groups have subgroups and are connected to other groups and so on, right? So you have group permissions that have other group permissions and so on attached to them. So one thing we can do is look at a set of hops through the network. So we want to say, we know there's multiple hops here. Let's go at least a hop of 1 up to any number of hops in the graph. Now, of course, you'll want to be a little bit careful if you have, millions, billions of nodes here that are all connected, because this query can overload. But for this particular data set, it's not a big deal because it's not overly complex here, not overly connected. If we had a high kind of important influential person in the network and, pulled their memberships, that might be a different story. But Henrietta is not in too bad a shape, right? She has a few direct groups, but then we can see this particular group, looks like an IT group here, kind of jumps off and springboards into other group access. And even this group has another group that it's attached to, right? So still, we have a few kind of directly related and then, a couple that kind of springboard off that, but we're talking maybe 10 groups that we have to mess with, right? Plus 3 machines. Still not too bad. But we know that groups also have access to machines. So let's take this even further and let's look at, we have groups, but actually I'm going to switch this up just a little bit because I'm going to change this to a path and I'll show you why in just a minute. So a whole path kind of pattern, if you will. So I'm going to remove all the kind of variables because we're going to reference the path as a whole. And then we want to see where they can RDP, those groups can RDP into computers. And we're going to return the path. Okay. Bigger. We're dealing with a bigger network now, but probably still manageable in the grand scheme of things, right? You're looking at, I don't know, maybe 10, 12 different machines, and maybe less than 10 groups that are connected here. But we still have some things, especially related to these subgroups, where these groups are connected to multiple machines, and so you have kind of this trailing depth of access, right? Now, Cypher is cool. We can write a lot of really powerful things here, but let's look at one other option for looking at this a little bit even more visually, and some things that you can do in our exploration tool, or Bloom, as we like to call it. So the nice thing is you can use Bloom to write natural language queries. So instead of knowing Cypher directly, you could kind of traverse the graph or the data using natural language. Find compute our users who can RDP into computers, and it will pull that pattern for you. There's also a little bit more power involved or available in Bloom if you save some Cypher statements. So if you have a developer or someone who's super technical and knows the system, write some Cypher queries for you, then business users or anybody who's maybe not as technical could actually just run these search phrases and pass in the values, again, more natural language, and those queries are going to get executed in the background. So for instance, what we just ran was this pattern right here. So match path with a user, member of a group. That group can RDP into a computer. So this is RDP access via groups for a user. Let's look at that. RDP access via groups for a user. Oops, that didn't work well. There we go. And then we know Henrietta Nordberg is our person of interest here. So we have this user in yellow. And then we have all of the groups she's connected to. And you can see here's that, kind of hopped down path, that kind of deeper network, the groups that connect to groups. And then all of the machines they're related to. So this is the exact same query we ran over here using Cypher directly. We're just seeing it, different colors. Of course, the coloration scheme is slightly different for this tab. So you might notice that we have a couple of machines out here that are colored differently, right? They're in purple. One of the another nice feature of Bloom is that you can do some rule-based styling. So for instance, we have a graph data science algorithm called PageRank that was run on a lot of the different nodes. And if you remember, I did kind of highlight this in the browser. We had a PageRank score. The machines that Henrietta was directly connected to were pretty low on the centrality or the importance scale, right? But we have other things here. So we have if they have a really, really low score, they're just colored in blue, which most of these machine nodes are. But if they have a midpoint score, like they're halfway between the spectrum of 0 and 1, then we're going to color them in purple. And then if they are really high centrality, really influential or important, critical in the network, we're going to color them red. So you can see we don't have any red colored machines in this, but we do have a couple of purple. So maybe we would want to make those assets and lock those down a little bit further, or if there was a breach, maybe we'd want to hit those points and lock those and shut those down first, or so on. We could help prioritize and kind of prevent further additional or worse damage, right? So again, still manageable at this point. But let's kind of dive onto this point, because it's not just RDP access, right? Maybe we want to see what all remote abilities are available by the groups for a particular user. So not only can they access machines, but they might have other permissions, right? They might be able to run applications or do some kind of low level things on the machine and so on. So this particular query, I can show you the saved Cypher here, remote abilities. So this is looking at a user that either can RDP into the machine, can execute DCOM, or is allowed to delegate to that particular machine. Okay, so again, more access, more capabilities that they can do on those particular machines, making it potentially worse of an exploit, right? So we have just a few extra nodes that were added here, an additional purple node, I think. Yeah, right here, execute decom to this machine, and you'll see it's colored purple. So it's a midpoint centrality, a little bit higher page rank than the rest. And so again, this would be something, we'd want to, she has execute decom permissions. So we'd want to check that out and vet that and see how important or critical we would need to approach that. So again, not a few machines, she has that execute decom access through the groups that she has access to. Okay. One last step here. So now we've got, our user here in the middle, the groups she has access to, the machines that she can not only access, but maybe do things on, or have certain permissions to execute some things. Let's look at all of the users that are connected to those machines as well. So now we're going to look at who could that person impact. We've got a couple different users saved, but we're just going to work with Henrietta. So now we're getting a pretty large data set size, right? This would be a lot of things just from one user being impacted or exploited or kind of hacked, for instance, the account compromised. Look at everything that it impacts. We can see kind of accounts over here. We have 33 computers, 11 groups, and 47 users that are impacted just from one compromised account, or potentially impacted from one compromised account, right? So again, we have this computer. These additional users have sessions on that computer. Zoom in just a little bit here. And you can kind of see we've got some other colors that are popping up. We've got another rule-based styling here. So we've applied on the user nodes. We've applied a Louvain, which is another, it's a community detection algorithm that's in our graph data science library. So we've looked at the different communities based on their each user's general network. So how they're connected, if they have, similar groups, similar permissions, similar kind of habits or so on. And you can assign communities based on those things. And so, for instance, people who work in the same kind of sphere or kind of have the same daily activities might be grouped into different communities. And we've colored each one of those. So we have our user here that's in yellow. And I don't see actually any other users in yellow here, but lots of them in green. But then we have, kind of these unusual, we have a blue, we have red up here. There's an orange down here. There's kind of this purple over here. And that means that, okay, if somebody gets access, they might be able to get access into another group or another team or another department, or someone else that has different sets of access, right? Because they're involved in different communities. So we might want to check out those pathways to try to prevent access through into other communities or other groups or other parts of the system, right? Okay, so that's a reasonably large network we have to deal with, but let's kind of look at maybe our more critical assets and see how somebody could get to that one. So for instance, let's go back to our Henrietta node. So we have a user. And this is kind of the natural language search here. We have a display name for that user. It's a property. And we want to type a value. Henrietta Norenberg. We're going to find that person's node. Come on, search. There we go. So there's our user, Henrietta. Now let's add to this and let's look for the group with a name of, well, hopefully I don't mistype this, domain admins at testlab.local. Okay. So now we have this kind of domain admin group that's out here. So now we're going to select both of these, and then I can right mouse click and do path, shortest path. So let's look at the shortest path between these two things. Ooh. So we have our domain admin group. We have Henrietta down here, and they're connected by one node. Sometimes, you have much more of a path, 2, 3, 5, 10 hops or whatever. This one has one. So we have this node here, which is a Abram Bumgarner that's in the middle. And you can see the relationship that's connecting them is they're similar by RDP. So we'd want to dig into this and look, okay, are they, do they have the same machines that they have access to, or maybe they just have similar permissions on various machines, or maybe they operate, they're both, colored yellow. So they both are in the same community, right? Maybe they operate within the same department, but the critical factor is if her account is compromised, it might not be too much of a stretch for someone to get access to Abram's account, and he has a direct membership to the admin account, which could be really bad. So we'd want to look into this a little bit more, figure out exactly how closely they're connected, how easy it would be for a hacker or a bad actor to get access to Abram's account and get to the domain admin kind of group there. Okay, so I'm just going to clear the scene here, and we're going to switch back and wrap up our content here. So first off, I have a bit of a promotion. If you're looking for more cybersecurity content or just general graph content in general, then check out our Nodes 2024 conference that's coming this fall. We have been running it since fall of 2019. It's focused on developers and data scientists, so very technical content. Last year specifically, we had lots of really excellent cybersecurity talks there. So if nothing else, feel free to go out to that link down there at the bottom of the slide, check it out, register for the event if you're interested. It is virtual, completely free, and it runs 24 hours of content, so across all different time zones. Also, if you have a graph-related story or cybersecurity story or something that you would like to submit, feel free to reach out for our call for papers. That's open till June 15th. We have a few different tracks that are going to be available, so submit your sessions, and we would love to have you speak and kind of get involved in the community there. Okay, so that's my highlight for now. So just looking back at what all we've covered today, I have a repository out there at that first link. So that includes the data set that you can basically reuse, load into your own system, and explore the data. You'll have access to the same tools that I did. If you use the dump file, it includes all of the graph algorithms that were run, the styling involved in Bloom, all of that will be there for you. I'm working on getting the CSV rendition of that load to match that. It's just not quite there yet. So keep posted for that. We also, if you want to spin up and not have maybe quite so much work involved, it's a little bit more involved to get the demo that I was doing today up and running. If you want to just kind of poke at it a little bit, feel free to spin up one of our sandboxes. It's very hands-on. They have the data. You choose the data set you want to load, and it will load the cybersecurity data set in, which is similar data to what I had today, but not exactly the same. But there's a nice guide that walks you through some of the cipher and the use case, and it covers some graph algorithms and how those get run and so on. So that's a really good starting point. If you're just looking for something, hey, I just want to spin up, I don't really want to have to do any kind of background work to load data in. And then next we have our Neo4j Graph Academy. So if you want to learn about Neo4j in general, or want to learn more about Cypher or data import or building applications with a variety of different programming languages, we also have some new kind of Gen AI LLM courses that are available out there if you want to look at how Neo4j operates in that Gen AI space. And then finally, kind of a callback to the previous slide, that link again for Nodes 2024. If you're interested, we would love to have you. So thank you again so much for being here. And again, my contact information's there in the lower left. So I'll stick around and answer some questions. But again, if you think of something later down the road, don't hesitate to reach out to me. Happy to talk tech. So thanks.
Hi again, Jennifer. Thank you so much for the talk. Also for the demo. We always love us some demos.
Me too. That's always my favorite part. It's maybe
Perfect.
a little bit more, maybe a little bit more stressful on me, but definitely my favorite. So.
Yeah, thanks for the hustle. All right. So Jennifer, yeah, we got some questions from our community and some minutes left. So I would say let's tackle them right away.
Okay.
First one. What basic skills or knowledge should someone have to work with graph databases in the field of cybersecurity?
Yeah, good question. So I would say probably just a little bit of knowledge of kind of how a graph database operates. It is different from relational databases, document databases, other types of NoSQL databases. The mentality is just a bit different, but like any other type of kind of different database, you're going to have that, right? There's going to be kind of a bit of a learning curve to understand what that database optimizes. In our case, relationships are elevated to the point that they're equally important to nodes. So that's how you get that network structure, right? Relationships are super important. They're not done at query time. They're done at write time when you write that data to the database. So again, a little bit of structure or knowledge about the structure of a graph and how it operates. Probably a little bit of Cypher. So want some kind of base query skills. That's usually really, really helpful. Other than that, you don't really have to have a lot. We have a lot of integrations. So if you're working with tools already, business intelligence tools, data messaging platform tools, applications with specific languages you prefer, all of that stuff has integrations to Neo4j. So hopefully you can just kind of plug and plug whatever tool you're using or application you're using into a graph database as well. So hopefully it's not a huge amount of lift there, but I would say just some base structure knowledge of the data model, a little bit of Cypher, and then whatever you're typically using hopefully is relatively easy to plug into a graph database. And then there's lots of tools. So I covered, the browser tool that you'll need a little bit of Cypher for, but you also have the Bloom tool that you don't have to have Cypher for. Of course, if somebody has, expert knowledge of Cypher, they can add some of those saved queries. That sometimes makes it nicer. But you shouldn't need, hopefully, too much skill to get started.
It sounds very easy when you talk about it and describe it. So
hopefully it is. Hopefully everybody finds it that easy. But yeah.
Perfect. Thank you so much. Let's move on to the next question. Yeah. Can graph databases be used to identify and track malware spread?
Yes. So I know there's some. I've seen some use cases out there for kind of tracking malware and bad URLs. So I haven't loaded that data in and checked it out personally, but I've seen some things about kind of following the path. So basically anywhere that if you have data to see the pathway or the network, for instance, that would be a good thing for graphs. So fraud detection, it's used quite a bit. So that's more kind of the finance and banking aspect of things, but even application dependency management. So that's one cybersecurity avenue. Malware, we looked at kind of RDP and access today. And then there's lots of different use cases across that. So I'm trying to think if there were specific things in last year's nodes. I haven't gotten to watch all of the videos from that just yet, but there might be some sessions out there, so content out there specifically on malware tracking using Neo4j, but I haven't specifically dug into that topic.
All right, maybe we can talk about it next time.
Yeah.
Thank you for answering this as well, Jennifer. Next question I was waiting for it. Is it possible to integrate machine learning or AI with graph databases to enhance the detection of cyber threats?
Yeah. I haven't seen specific use cases in this just yet. But again, AI is still new, right? We're still figuring out all the different ways we can utilize it. But for Neo4j, we have some integrations with different large language models. Of course, different ways that you can plug that into applications that already exist. There should be really excellent ways to do this, where you could put an LLM or even just, let me back up a little bit. Even the AI component with the LLM would be super powerful, but outside of that, we do have ways and integrations that have been done before for machine learning techniques. I would say check out our graph data science library. And I'm trying to think what else would need to go along with that, but we get involved in kind of machine learning. It's not paths. I'm trying to think of the like systems or processes where Neo4j is a component of that. So you can run algorithms to kind of surface key features and do kind of prediction learning or machine learning aspects on that data, and then kind of kind of spit out those results. And it's the machine learning that we do is based on the network. So it's not based on just like property values or other things like you might see in other types of data stores. You can also do machine learning and pick out key features that are based on the network, how connected a node is, or how many connections they might have, or certain types of connections or other people, communities they might be involved in, and so on. So machine learning for graph is a little bit different because you take that network into account, or you can when you do it. But yeah, there's a couple of different avenues you can take with that: traditional machine learning or kind of the newer Gen AI spectrum of things too. And Neo4j has some things in the machine learning space. We also have some things and are still working on additional things in that Gen AI space, as are probably all of us, right?
So yeah, a bright future ahead of us, the AI future, also with Neo4j. Perfect. So yeah, maybe in 1 year we can talk about like the new AI features.
Yeah, it'll be totally different in a year, right?
Yeah. So, and let's take this question. In terms of cyber threat analysis, what limitations do you see with current graph database technology, and how might they be tackled in the future?
Well, I would say probably the biggest problem is just data and good data, right? So being able to tech moves very fast, and of course, cybersecurity tries to move faster than the people defending it, right? So your attackers in some ways are always going to come up with new and inventive ways to get into a system. And so having good data that you can anticipate those and prepare for new or respond to new ways to get into a system, I think is super critical and super valuable. And not only affects, graph databases, but lots of other systems as well, lots of other databases, and even, people, we have to be on top of things and make sure things are good. But getting good data in and then maintaining that good data, I think is a constant battle for all of us, dealing with data, right? Your solution's only as good as your data. And so I think that's the thing to try to stay ahead of. And that's something that we'll probably see better ways to do that as maybe hopefully AI comes into play a little bit more. There will be some things that AI can be faster and more adept at catching and handling and kind of speeding up the process for us defending. But there will always be things that, we'll miss or not have current and the right data that we need in order to prevent something or respond to something as accurately as what we'd like. So.
Yeah, and it works both ways, doesn't it? So also the attackers can use AI to find holes in the system.
Yeah, and then we'll just look for the next thing to try to outrun them.
So yeah, thank you for that answer as well, Jennifer. We got another question for you.
Okay.
How do you ensure data integrity and prevent contamination when importing cyber data into graph databases?
Yep, another great question. So there's some ways that you can kind of, I would say, create some boundaries for the data that when you put it in. It's not as strict as other systems out there, but that is the goal. That's the design of it, right? You want to be flexible. The data model is meant to move and try to keep up quickly with business and the data that you're getting. So it will be pretty flexible as far as kind of data model and structure. But there are definitely some constraints you can put in place. There are access controls you can put in place so that you avoid kind of putting bad or unclean data in. So you can set some, unique constraints. You can create we expect this property to kind of look like this, or we expect these entities to have this particular property, or we don't want new properties added to this general subgraph or so on. So again, ways that you can kind of set up those boundaries and those limitations. But again, realizing that the highlight of a graph database is being able to move flexibly and keep up with all the data and the variety of different data structures that you're having to dump into it and try to analyze quickly so that you can be up to speed on the business.
Thanks, Jennifer. We got one more community question.
Sure.
Here it is. What strategies do you use to maintain the security and privacy of data in graph databases used for cybersecurity analysis?
Yeah, so there's lots of options here. So most of the capabilities that lots of other database vendors will provide, we have those same provisions as well. So things like role-based access controls, limiting who can make edits or changes in the graph. We also have, if you're hosting Neo4j in the cloud, you can do subscriptions for like your own virtual private network, or you can share cloud machines with other customers if that's comfortable, or so on. So there's lots of different options there for how sensitive your data is, how critical it is, and kind of locking down that system to ensure kind of minimal security exposure there. As far as other types of strategies, you can kind of set up the data in a way, organize the data in a way that makes it easy for you to put those access controls, so the role-based access controls on. So for instance, some users might have view access to everything. Some users might have view access to, let's say, diagnosis, like medical diagnosis nodes, but they wouldn't have access. They could see patient nodes, but they couldn't access the metadata, the properties that are involved in that. It's only like a pass-through node to get to other parts of the network. So there's different ways that you can set up, even just people querying and exploring the graph, different permissions you can set up for, hey, okay, you can look at this part of the network, but you can't edit anything, or you can't view the sensitive data that's here. So again, a few different aspects depending on what type of strategy they're looking at, whether that's like the hosting and running Neo4j, or whether it's actually looking at the data inside the graph, that you can kind of go about this question.
All right. Thank you so much, Jennifer. This was the last community question, but maybe before you leave, would you mind? I asked everybody today, every speaker, how they first became interested in tech. Would you mind sharing your developer journey real quick with us before we end the session?
Yeah, so I came by it a little bit, I guess, honestly. Both my parents were involved in technology. Of course, I kind of took a different path growing up. I really enjoyed music. And so I kind of pursued music initially. But I knew kind of the technical skills, being able to use, computer and even just kind of basic code skills are important. And so I had a few different forays into that. I had like a web design kind of summer camp when I was a kid. And then I took a programming class or two in college. And when I took Java specifically, I really thought, hey, this is, it actually kind of overlaps and aligns with some of the things in music as well, kind of using both left and right brains. But I really kind of enjoyed the programming aspect. I'm like, you know what? I enjoy music. I still enjoy music. But this is really cool. And there's lots of things you can do in technology that maybe other industries you don't have access to. So I kind of, I wrapped up my major at the time, had a business minor along with that. So again, I took some additional tech classes as part of that, which was a lot of fun. And then I moved straight into CMIS, Computer Management Information Systems, master's degree, and took then very technical classes and got a job and started working full-time in the space, and just really enjoyed the world that technology opens and all the opportunities there are. Whether that's through music or helping people in the medical space, or humanitarian aid, or just even writing programs and dealing with data. Data is fascinating. So it's just a really fun environment, very intense, very fast paced, but you're never bored. So I love it.
Yeah, that's awesome. You certainly sound very enthusiastic when you talk all about this. So. All right. Then, Jennifer, thanks so much for sharing so much knowledge with us today. It was a pleasure having you again. Thanks also for getting up early for us. I hope you enjoyed your morning coffee together with us.
Yes.
And yeah, hopefully we see each other again on another live day.
Thank you. Bye.
Thanks, Jennifer. Bye. All right. And now that also this live day comes to an end, a quick reminder to check out vaultcongress.dev. There you get further information on our upcoming World Congress. It's from July 17th to 19th in Berlin this year. And yeah, prices increase on Friday, ticket prices. So yeah, make sure to grab your tickets on worldcongress.dev. Also, of course, thanks to our partners, scroll down on the live page and yeah, check out what they can have to offer. And yeah, hopefully we see each other again on the next live day on May 22nd, when it's all about machine learning. Stay tuned. Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.